someone do like just a test on the mic? Yo, so YouTube stream got temporarily, so it's back up. I just need to make sure that the mics and stuff is
Microphone
set up
check.
here correctly.
1, 2, what is this?
Can you hear that?
Yeah, I can hear that. One sec.
Yeah,
Yeah, we're good.
Wait.
I can hear myself.
Bluetooth start?
It's coming from his mic.
Hold up.
Test. I think I heard it that time. Microphone check.
Is it okay? Okay, good afternoon, everyone. We are ready to start our second session. Right, so sorry for a slight delay. We are trying to get our online session also started. So our next speaker is Kurt Kremitsky. He is an agriculture and biology engineer, and he's also a Debian developer. He is also an active project contributor of the FreeCAD project that he will be talking to us now in the afternoon. He is also about to embark on his master's degree next year. So help me welcome him, everyone.
Thank you. Hello, everyone. So my name is Kurt Kremitsky, as she mentioned. I'm here today to talk about FreeCAD in Ubuntu. And I just wanted to thank you all for coming and also give a quick thanks to everyone who was involved with bringing us together today. So the structure of my talk, I'm going to kind of just start quickly with some background and then talk about the details of FreeCAD before I get into sort of packaging details. And so I guess just first, I'm not going to assume anyone actually knows what CAD is, so just the definition of that is computer-aided design. And so FreeCAD is actually not only a CAD program, you might more accurately call it a CAX program because it also pulls computers into helping with manufacturing and engineering. And so we have a sort of a detailed history wiki page if anyone is interested in sort of the background of the project, because it has been around for quite some time. As I have here, you see in 2001, the project was sort of initially announced, although that wasn't the initial release date. And the project founder was Jürgen Riegel, and he also had Werner Meyer working with him at the time. Currently, Jürgen is not really participating in the project anymore, and so Werner is sort of the project lead. One of the other main developers, Jörg van Hav, he joined the project around 2008. And so he is an architect, and he was able to bring that experience to bear towards the project, and so that's one of the main areas that he works on. One other sort of important developer who has recently joined the project is a person by the name of Jung Lei, who goes by Real Thunder on the forums. And I just wanted to mention him because I'm going to be talking about some of his efforts later on. He's working on some sort of major overhauls to the internals of FreeCAD. And so doing that, there's some major difficulties, and we're going to talk about some of the ways that he's dealing with that. And so just a quick introduction, a little bit of details about myself. Some of this has already kind of been mentioned. Biosystems engineer, I choose that just because biological and agricultural engineering is way too much of a mouthful. And then I am a Debian developer, which is not just someone who works on the project, but is basically the D is capitalized because that means that I'm a full project member. And I contribute to Ubuntu, but I don't really have any formal structure with the project in the same way. And just to unwind and enjoy myself, every now and then I get a chance to play fighting games on Linux. And I dabble in a couple other types of games, but that's probably 80% of what I do. And so I want to talk a little bit about why people are interested in FreeCAD and why I chose it as well. This first bullet, I wasn't really sure how to phrase it because I kind of didn't want to name any names, and it's sort of a general thing, but the incumbents in CAD software, they have a very, very strong incumbency, and so they're not really pressured to make changes that people really appreciate. More often, the changes that they make drive people towards FreeCAD, and so recognizing the issues with their behavior is one reason why I am interested in the FreeCAD project. And this is not just true. I specifically said incumbents because it's not just CAD software. CAD is also part of Windows entrenchment as well. Besides gaming, those are sort of two major areas: the advanced engineering applications and then games. And then obviously this last bullet point, I dropped that not to dazzle people with dollar signs, but just to kind of indicate the significance of CAD software in our society. It underlies a lot of pretty major things, especially even going forward. I think it's just going to increase. And so I mentioned this earlier, just sort of the rough structure of my talk. I'm going to give sort of a tour of FreeCAD where I talk about the workbenches, which is sort of the main way that the code is structured in the program. And then I'm also going to talk about what I term the cast of characters, which is dependencies and optional integrations, you might say. But because there's so many of them and you have different programming languages, different governance structures and stuff like that, it's not necessarily just a dependency, or a dependency that is not quite enough of a word for it. And then also, I'm going to touch a little bit on some news in the project, as well as sort of where we're going. And then hopefully we'll have a little bit of time for some questions and answers at the end there. And so some of the things that I was hoping that the audience would take from this talk, I say here rally for FreeCAD, but it's really kind of goes towards my own background in the project. When I first started, I wasn't really capable of doing very much, but I recognized that there were some, I guess you could say minutia or busy work that some of the more capable people in the project were involved with. And by looking and trying to find those things that I could help with, I was able to free up time for them so that they could work on things that were maybe more impactful that I couldn't work on. And so really any little bit of effort that people try to contribute can have that effect. And even if you aren't necessarily able to make deep underlying changes like Real Thunder is, for example, you can still free up someone else who could free up someone else who could free up something he's working on. And besides that, I just wanted to share sort of some of the things that I've learned packaging FreeCAD. And it's not quite a reference because it's just too much that I could really fit into this talk. But at the very least, I kind of name drop some things that people can go and look up later and just talk about some of the relationships between the different packaging tools and the sort of hierarchy or trade-offs that you have by choosing them. And so one of the first things, like I mentioned, is the workbench structure, which is it's very central to FreeCAD. There's several, I guess, decisions or advantages for doing this. One of them is just that, FreeCAD is a pretty big program, and if you had to compile it every single time you wanted to make a change, not only would that just take a lot of time, but it's not very user-friendly. And so we can sort of have loadable code that third-party developers can distribute easily, and people can just copy the files into their computer, and it can load the code dynamically. And one of the other big advantages is that FreeCAD's scope is ridiculous, and so if it had to load all the code for all possible functionality as soon as it started, it would just take too long. And this way, you can just kind of load the code as needed. And one of the other things is that the workbench structure, there's a lot of dynamic modification of FreeCAD, so that, for example, it's possible that if you load one workbench and then another and then go back, you may not have deterministic behavior. Or I guess you might say it's not necessarily idempotent to load a workbench. And so I guess I wanted to talk a little bit about some of the details on this slide, because this is a diagram specifically for the part workbench, which is one of the more fundamental workbenches in FreeCAD. And so at the very bottom there's a bar that says Open Cascade Technology, which is basically the central library for FreeCAD, which I'll touch on a little bit later. But part is sort of just a wrapper on top of it, which among other things provides just a very basic Python API to Open Cascade's C++ code. And then the sort of primitives that it allows people to interact with that can then be used in other workbenches. And so above that, you have a line of different workbenches: part design, sketcher, draft, arc, or arch for architecture. And then above that, you have sort of the actual types of objects that are involved. So you might have like a solid, for example, part. So let's say you just create a cube. Simple enough. A sketch, you may have a wire that would indicate sort of the outline of the base of that cube. And then also there's sort of the solid on the outside, which indicates the data interchange. So we can take something that wasn't made in FreeCAD and start modifying as well. And so I mentioned workbenches, but sort of a higher level concept is the idea of workflows. And I kind of talked a little bit about that with how, for example, you can use like the wire around sketch. A wire sketch can then be used to, let's say, extrude a cube or something like that. And so one of the sort of ultimate workbenches, and I mean that in the sense that it's one of the final things that you do, is the FEM workbench. And I'm going to, let's see, so FEM is it's finite element method. Not really going to go into too much detail on that because it's a pretty deep topic, but basically it's a way to take sort of strange shapes and very difficult math and break it into, let's say, triangles and problems that are in the domain of linear algebra as compared to like partial differential equations or something. And so one other thing that this slide has is it's a bit of a preview of some of the components I'm going to talk about later with Gmesh NetGen down there. Those are two solvers, those are two meshers, excuse me. Two meshers that are used, like I mentioned, to break down these strange shapes into more manageable things like triangles. And then to the right of that is the solvers. And so those are things that actually take sort of the engineering constraints. So let's say, for example, the behavior of a material under load or something like that. And it goes and does the math on those triangles to see what the outcome will be. And so the FEM workbench, like I mentioned, it's a good example of the workflow where you would produce a shape or something like that in another workbench, and then you would load it, you would load the FEM workbench and then go in there and do your analysis. And there's also options for post-processing. And so some of that actually is possible within FreeCAD, but you can also just send it off to something like ParaView or a renderer, for example. And so now I'm going to kind of go through sort of a tour of various major workbenches. Draft. This one it's very similar to, let's say, AutoCAD, for example, in that if you're used to working just on a 2D grid and just drawing shapes directly, you can do that. But FreeCAD is FreeCAD is a 3D CAD, and so you aren't necessarily restricted to actually only working in the plane, as you can see in the shape down there. And so this is not actually a workbench, but this is kind of a preview. This is sort of a type of modeling, I guess you could say. There's two main paradigms in FreeCAD. This is sort of the more basic one, and if you kind of look at the bottom of this diagram, on the left, for example, you see that we have 3 cylinders, and then those are joined in an operation union so that we have all the components and all of the pieces. And then on the right, we have a cube and a sphere, and we have the common or intersection operation, and then we take those two results and then combine them with a cut to end up with our final product. The only problem with this is that it's very, very manual. It's rather than something that you can program, you have to go in and place the pieces and put together the sort of the operations that relate them to the end product. And so, for example, if you change your mind and say you wanted to, instead of that particular cube, you wanted maybe one that's a little bigger, it isn't necessarily easy to go in and make that change. You have to sort of redo the process. And like I mentioned, there's 2 main paradigms. I just described the CSG one, and the next one is the parametric approach, which is really what FreeCAD is for, but it's not required to actually use it in that way. And so in terms of parametric design, we start with the Sketcher workbench, which is it's restricted to working in a plane. And so in this picture, we have various colored objects. You can see there's some of them are green, some of them are red, some of them are blue. And so we are working with the geometry, which is the green stuff. Then there are constraints. So for example, you can see there's like an arc constraint on the outside left, and there are also some, dimensional constraints on the inside that say that, these pieces need to be so far apart from each other. And then we have construction geometry in blue, which is just a way of having a reference without actually having something that is actually a physical component or a real component in the sketch. And so, like I mentioned, parametric design starts from the sketch. And so in this case, I'm starting just with a trapezoid. And so this is going to showcase, just through a few quick screenshots, the behavior of the part design workbench, which is sort of the main parametric design one. And so we start here, like I said, with a trapezoid, which is fully constrained. And so there's geometry, which is fully specified as far as where it should be, rather than something that could be moved within the plane, for example, or stretched and made larger. And so with that sketch, we then do an extrusion operation where we take the trapezoid and just push it in some direction for some length. And then we have another sketch here. And in this case, the sketch is actually on top of what we were just looking at. And it's just a simple square that we're going to use as the base for the operation. And we're actually doing a cut operation and then also a mirror, so that we're taking those two pieces out from the top. And so kind of going back to the sketch, what we're looking at here, if I were to go in that sketch and change one of those, let's say, distance constraints, I could, it's not automatic, but this whole thing would recalculate. And so the difficulty is that right now in FreeCAD, there's a possibility of instability for that recalculation. And so it's one of the main, I guess, problems facing the project, because when someone makes a complicated model, they don't want to, that they want to be able to interact with parametrically. They don't want to have to go in and redo it because something broke. And so that problem, it's called the topological naming problem, and that is sort of the main thing that Real Thunder has been working on. But the difficulty is that it's a very intensive change. And so one of the other, I guess, main shortcomings to FreeCAD is that we don't actually have a native assembly workbench. And so once you're done with part design and you've made, let's say, this screw, you're going to want to define its relationships to other parts. So for example, this washer, we wouldn't want it to be on the other side of the nut. And we wouldn't want it to be, beyond the screw or something like that. And so I put that asterisk there because there's I'm not sure the exact count, but there is at least, for example, an Assembly 4 workbench, an Assembly 3 workbench, Assembly 2, Assembly 2+. And these are all just people trying to come up with implementations that the project will ultimately adapt. And so one other thing, Real Thunder is also working on, his is the Assembly 3 workbench. And so it's possible with maybe the next release, which I'm going to get to at the end, that we may integrate that. And we're considering that once the assembly situation and the topological naming problem situation are resolved, that we may decide to finally have a 1.0 release. And so once you come up with a part, it may just be a model of a part that's already off the shelf, but you may want to have someone actually manufacture it, and that person may be used to working with paper drawings. It's not really uncommon. And so it's possible to take that part. This is the finished part with a few more operations added to it, and then produce this technical drawing which shows the dimensions of it, and you can have different views and things like that, so that you can communicate what you think is important for the person to actually make that piece. So this is the FEM workbench that I mentioned earlier. And so this is just a classic example of beam bending, where you have just some sort of piece of material and there's a load attached to it, and you want to see how it bends. And so this is sort of a fundamental thing in the mechanics of materials. And so in this picture, I also wanted to mention that we have the original beam, and then we have sort of a colored beam, which is it's deflected. And so this is actually what I mentioned earlier, where there's post-processing options inside FreeCAD, and this is using VTK, which I'm going to get to in just a moment. One of the other interesting applications, engineering applications with FreeCAD is CFD, or computational fluid dynamics. And so this screenshot is someone's project where they just did a very simple case of 2D flow. And you can see sort of the streamlines where along the line the fluid is moving at a particular rate. And so under the hood, this uses a project called OpenFoam. And there's some interesting implications there because FreeCAD is LGPL licensed and OpenFoam is GPL licensed. And so even though we have a Workbench that uses OpenFoam, we can't actually distribute it directly. And so we have to use the binaries provided by the package. So I mentioned manufacturing of parts, and so this is one of the things I think is most interesting in terms of potential for FreeCAD. You see here we have a plastic brick, and there are sort of green and red lines indicating the path that would be taken by the hot end of a 3D printer, for example. And I think that this screenshot is not quite the path that would be required to make this, but it's something else. But it's just a very relatable example of a plastic brick. And so one thing that would be interesting about this is that you can create a model in FreeCAD, and you can go in and you can produce this. This is called G-code, by the way, which is the machine code used by these devices that describe the actual path that it needs to take. And so it's possible, once you have this G-code, to do something kind of like file print, let's say, where you send it off to a 3D printer, and then if it's set up, you just go pick up your part at some point later on. So I mentioned 3D printing, but that was actually the path workbench, which is more general than that. It can be used for what we might call additive and subtractive manufacturing. And so what we have here is just a simulation of the results of the end of a tool following the path that was produced by that G-code. And so we can see basically the thing getting carved out here. And so this is a very interesting aspect because the title of this slide is CNC milling, but it's more general than that. People, for example, use laser cutters or hot wire devices to cut pieces of foam. So I know one person uses that to make prototypes for boats. And so we're getting now to the section of the talk where I talk about sort of the components or the cast of characters. And there's a little quote here, just a kind of woe is me type of thing where FreeCAD, we never met a dependency it didn't like. And so people find something interesting, they want to see if it works. And if it does, it kind of just sticks around. And so it's not necessarily something that you can deal with, or that you can control, you just kind of have to deal with. And so I guess the most fundamental aspect of FreeCAD is the application framework that we're using, which is Qt. And so this is what is responsible for us being a cross-platform application. Part of the project's goal is that we can run on everything, although in practice that's limited by developer bandwidth. And so when you have people who are capable of working on CAD, you don't really want to have them be messing on, let's say, widgets on different platforms. And so it's nice that Qt is able to take care of a lot of these things for us, but it would be better sometimes, possibly, if people had even more, let's say, wish list, if FreeCAD had some KDE components, for example. And so the next major component of FreeCAD is Open Cascade, and that's some people call the CAD kernel, or it's the library that is responsible for those operations that I mentioned earlier, like cuts and unions, and even for creating the primitives like the cubes and the spheres and cylinders and so forth. And so Open Cascade is kind of an interesting project. It's definitely a big contributor to the complexity and difficulties of FreeCAD because part of the reason, at least, is that it's been around for a while. And so since they were solving problems that were solved by later standards of C++, they have their own implementations. And so, for example, like a smart pointer. And so that makes it, it's sort of got all this legacy, I wouldn't necessarily say baggage, but it makes it somewhat more difficult to contribute. And so one thing that would be nice in terms of a potential future is, let's say, for example, with Open Cascade, a part of it is responsible for the interchange of data and file format support. And so there's sort of a security surface there And so, just for example, if we were able to take parts of Open Cascade and re-implement it in, rewrite it in Rust, not to really suggest that, but something like that could potentially have beneficial impacts on the health of the project and CAD and open source in general. And so it originally started as a commercial project, but they relicensed it, and so that's sort of how FreeCAD actually was born. You notice that the relicense was in 1999, and the project started in 2001. And just another sort of signal of, I guess, the nature of the project is that the only bindings that they actually provide, and which they also require bug reports to be reproducible with, is in Tickle. And so there are Python bindings, but it's a third-party project. There's a PyOCCT, I should say, in addition to FreeCAD's Python bindings. And so one of the next major components for FreeCAD is Coin3D, which also was, I guess, released to community, if you will, from a commercial project. And it's a scene graph library, which it's kind of a complicated topic, but I guess a scene graph is a way of dealing with all the things that you were looking at in a way that doesn't require you to draw all of them, even if you're not looking at them, for example. And so it is based on OpenGPL, and so it is what is responsible for taking care of that aspect of FreeCAD for us, essentially. And it's an implementation of the Open Inventor API, which was, I think SGI was behind, and so part of the difficulty, the reason Coin was released to community was that SGI opened up Open Inventor, and all of a sudden the commercial aspect, the landscape changed. And one thing that's interesting about this, I mentioned FreeCAD is LGPL licensed, and Coin3D was relicensed from GPL in 2011. And so I haven't done the digging on this, but I just wonder if from the 2001 to 2011 period, if FreeCAD was technically potentially having license issues by being a GPL plus LGPL. Or rather, I guess it was FreeCAD at that point probably was just GPL. And here's one of the other components of FreeCAD, VTK, which is the visualization toolkit. And so we use that for some post-processing within FreeCAD. And so, for example, I mentioned that in the picture earlier we had a beam, and then we saw the deflected beam. And the beam is the only real object. The deflected beam is sort of just a visualization. And so in this case, for example, we have some house type of structure with some load on the top. And realistically, if this house was deformed in this way, it would explode or something. And so there's a scale factor so that you can exaggerate the impacts of the loading situation of your part. And so this is a screenshot from Gmesh, which is one of the main meshing tools that FreeCAD uses, in addition to NetGen. And so whenever we have sort of those engineering analysis type programs, we rely on these as sort of a first step. And I mentioned OpenFOAM earlier. It's the general category of solvers. This is a screenshot from Calculix, which is what we use for example, the screenshot of the deflected beam was produced with Calculix. And so this screenshot is interesting. It's showing the eigenmodes of this compressor. And so that's basically the behavior of the part under vibration, or and so one thing that's you might not think that this is necessarily something you have to worry about, but it's actually quite a bit of a problem if you have a part that you were not expecting to vibrate and then it starts vibrating. And a really famous example of this is the Tacoma Narrows Bridge. If anyone has not heard of that, I would suggest going on YouTube and pulling up the video. Okay, so now we're to the packaging tools aspect of the talk. And so, like I mentioned, this is largely beyond the scope of the project, but just kind of the scope of the talk, but kind of starting from the beginning. When you're building FreeCAD, for example, on your own machine, you would issue like a CMake command with some flags set, and then like a make command to actually do the building. And so depackage build package is a way to take the packaged version of a software and then use the, let's say, installed dependencies on your machine to just run through the steps of packaging. And so if you were wanting to produce a FreeCAD package, this would be one of the first steps that you would do. The downside to that, though, is that you actually have to have the packages installed. And if you install all the packages for all the things you ever would want to build, you can have a pretty messy system. And so it's nice to use some isolation. And there's many options for that. The next item mentioned here, debuild or debuild, is just the first command in addition to lintian, which is another, I guess, foundational tool in the Debian and Ubuntu ecosystem. It's a linter for Debian packages. And so let's say, for example, you have there's all sorts of problems that are checked by this tool, and it'll let you know what the health or the health of your package is. And so I mentioned earlier that the problem with depackage build package is that you have to install all the dependencies. So for FreeCAD, that's a lot. And so if you aren't using them, you may not want to keep them around. And so sbuild is sort of the next level of tool that you would use when you want to have a clean build. And it uses troots or chroots, which is just a way of kind of having all the base packages of a Debian Ubuntu system sort of isolated at a file system level. And so a couple of the packaging QA tools that I use in FreeCAD. Auto package test is just a way of taking the binary packages produced by the build and then using the tests that are in the source package and making sure that they work together. And so one example of a problem that this could catch is if you have a situation where the test only passes when it's actually inside of the build versus the produced binaries. And so another level of I guess, quality that is something that I'm interested in kind of for the whole FreeCAD ecosystem is repro test. And so depending upon how you build things, for example, there can be things like dates embedded inside the files. And so if you were to build it once and then again, you would not actually have the same checksum for the files. And so you don't necessarily know, for example, if something else has changed. And repro test is a way of going in and doing things that could potentially cause differences in the produced files and identifying them. And so if you can pass repro test, it's a really nice property of the package to be reproducible. And so because there's a whole ecosystem of dependencies with FreeCAD, if you make a change at sort of a low level, you may need to do a lot of builds of other packages using that new package. And so rat, or rebuild all the things, is another thing that's pretty useful if you're dealing with these types of problems. And so I mentioned how depackage build package, you sort of build on your system, and even sbuild does the same. And so the problem with that is that if you want to continue to use your machine, for example, it can be sort of a pain. And so it's nice to just have a remote build server, and Launchpad is a really nice way of doing that. And there are several different ways that you can interact with Launchpad. You can actually just upload binary packages. So for example, if I had something produced by depackage build package, which could have some undesired change because of the dirty build environment, I could still send that on up. And so it's accepted, but not necessarily ideal. And so instead, Launchpad uses something called recipes, which, so for example, a very simple recipe would be FreeCAD, the Git repository for FreeCAD, and then the examples are actually removed from Debian because of DFSG reasons. And so we can just kind of take those removed examples and just put them back in Ubuntu. And so with recipes, you still need to specify the actual Git repository. And so for example, you're going to need to have that Git repository on Launchpad. But then if you have to maintain the one that you're actually working in and the one that's being used for your build, that can be an issue. You would want to have some sort of automatic updating process. And so I'm going to do a bit of a no-no here, which is sort of a bug report by talk. But with Launchpad, you can go in and point you can point a repo on Launchpad to something on Salsa, which is Debian's GitLab repository. The only difficulty with this is that it's only allowed to have one. And so, for example, if someone else has already gone in and made a automatic mirror of a package on Salsa, then you cannot do it yourself. And this wouldn't necessarily be a problem, except they can update the URL that is pointed to. And so if you were to just go ahead and assume that you can use it, you could potentially expose yourself to a security issue. And so yeah, just maybe a little bit of change would be required there to make it a little easier, because this is actually something that specifically has happened to me, where someone else has kind of already taken a mirrored package, and so I have the choice, which I won't take, of using that, and so I just kind of have to manually deal with that. But luckily, it's a minor dependency, and so it's not something I have to update very often. And so, as a Debian developer, I am kind of starting from the bottom in terms of providing, debs for people who use them because people like them. But I also want to, have things in a PPA because people use that as well. And even the same goes for snaps, which I'm going to get to in a moment. The only thing, though, is that PPAs are fundamentally unsuitable for a couple of reasons. And I've actually had breakdowns happen. So FreeCAD, for example, is in an ecosystem of advanced applications. KeyCAD is one of them. And there's actually a dependency in KeyCAD on FreeCAD. And so those two PPAs had their own versions of Open Cascade. And that resulted in those PPAs not being, it's not possible to use both of them at the same time on the same machine. And it's really, really not desirable because people use them in conjunction. And so it's more common in that case. It's also the case sometimes that people use QGIS, which is a Geospatial Information Systems program, on the same machine as FreeCAD. And I've had a problem before where they updated the version of GDAL, which is a Geospatial Data Abstraction Library, on their PPA, and all of a sudden co-installability was broken. And so as much as I like debs and PPAs and things like that, you kind of have to cover all of your bases. And so I am not personally maintaining the FreeCAD snap, but I do know that in addition to the main one, Real Thunder is actually using snaps as well. And part of the reason for that is that with the PPAs, for example, we have the FreeCAD PPA and then a daily PPA. And this is something that I could fix, but they're not co-installable. And so I basically go in there and set FreeCAD to FreeCAD daily, and that way we have separate paths. But this is not really correct. And so with snaps, you get rid of that co-installability problem. And so one other thing is that Real Thunder's changes are very fundamental. And so he's making these adaptions that can't be distributed, or it requires recompilation, I should say. And so it's a kind of a pain. He can't just, put up a release file or something like that, of like Python Workbench, for example. And so because he's making very invasive changes, I guess you could say, he's taking advantage of the channel support in Snap, which is, more of an appropriate way of handling the FreeCAD daily sort of division. And so he's actually able to get people to get sort of the get head version of his changes in a very, very easy way that doesn't require any building on his own machine or anything like that. And so even though I am not involved with them, it's kind of apparent that, we do need them as well. And so I mentioned earlier the topological naming problem, TNP, is sort of one of the elephant in the room with FreeCAD, and I just wanted to kind of explain that briefly. And so this is sort of an illustration of how the problem can arise. And so if you look at the shape on the bottom, you've got faces, and if you want to refer to a face, you might give it a name, like let's say face 1, face 2, and so forth. And so in order to assign names to all the faces of a shape, you have to have some algorithm for doing it. And you want it to be predictable, because in the example of this shape, let's say, for example, the bottom shape, let's say what the top shape is resting on is like face N. If I were to go in there and cut a groove in between the left and the right side, it would produce two different faces. And so if that top shape was attached to face N, we would want face N to be what's on the left as compared to on the right. And the difficulty with this is that it's actually possible to produce, let's say if instead of cutting cleanly to the side of that top shape, I were to go diagonally or something, that actually should not work at that point. So you can't, you have to be very, very careful with the algorithm for naming. And so it's a very difficult problem. That's what Real Thunder has actually been able to largely solve. The stability, it is still possible, like I mentioned, to break the model, but you don't want it to break when it shouldn't, on accident or something. And so this is an example of what people are using to get around the TNP situation right now. So I mentioned that in that case, if we had the top shape attached to a face in, then if that face were to be recalculated and split into two faces, it's not clear which one it should attach to. And so instead, let's say, for example, the height of that bottom shape was defined by some parameter h, and then we could have a datum plane, which are these sort of yellow objects. And the datum plane, for example, would be only dependent on that parameter h, rather than the name of a face. The problem with this is it's just more work. And so even though it is, when you model in this way, it is extremely robust, it's not always what you want to do. And so we should allow people to use the program in not just the most correct way. And so FreeCAD 1.0 potentially is on the horizon with some of the changes that have been made recently, which is really incredible. The TNP fix it's been a while because last I saw, it's something like 70 to 100,000 lines of code changed. And so that has to be broken into many, sort of atomic changes rather than a single change set. And so it's something that's taken quite a time and caused a bit of division, but it seems like things may be kind of coming back together soon. But the problem is this sort of invites a terrible amount of bike shedding, because people, if we're going to change our version from currently 0.20 to 1.0, should we actually even use semantic versioning? Like, is the advantage of that worth it for us? Some people are wanting to do calendar versioning. And there's lots of different discussions going on about this, but it's nice because we're actually getting to the point where we could make a change based on this discussion rather than just spinning our wheels. And so if anyone is interested, we are planning a FreeCAD meetup on the Friday before FOSDEM. And in addition to the potential for in-person collaboration there, it's also possible to just keep track of project news. We have a blog which has kind of just recently been created, and so some people are running that. And another very interesting piece of news with FreeCAD, in case anyone hasn't heard, is we actually formed a nonprofit organization in Belgium. It's Association sans but lucratif, to be specific. And so it's been a really interesting change because formalizing governance, we kind of learn as we go and find things that we need to potentially change. But the big takeaway from us having formed this is that it is now easier for us to receive money, and there's more of an incentive due to tax purposes. But spending it remains really difficult. And even before this project association, that was sort of the main difficulty. It's not only spending it just in terms of ways that are above board, but also ways that people won't have problems with in the project. And so we're coming to the end of the talk now, and so I just wanted to kind of drop a few references here as far as how people can potentially help. We have an entire wiki page which is dedicated to getting people onboarded to the project. And we also have a LibrePay account which is shared among several developers. And so I'd say that's probably the preferable way if anyone were wanting to do financial assistance. And then I also have my own Patreon as well. But I would say the main thing is that, like I mentioned, the point of this talk is to kind of rally people towards FreeCAD, so that even if you are only able to do something that might seem small, it actually could have a pretty significant impact. All right, so that's my talk. Thank you, everyone.
Thank you, Kat. Okay, we have our volunteers ready to bring the mic around if you have a question. Okay.
Hello.
Hello.
Has the 3D printing revolution changed your kind of approach to FreeCAD?
Well, it's definitely, that's where the people are. And so I don't know if it's necessarily changed so much, but, we kind of, so for example, I mentioned how, incumbent CAD programs do things that tend to drive people towards us. We recognize that 3D printing is the same way. And so we kind of have to be ready to receive people when that is the interest that brings them to us. But I would say it's probably increased the entire ecosystem is growing, and so as a result, we've also had growth because of that.
I just haven't found a great open source solution. I mean, I often find myself using OpenSCAD, where I'd rather use FreeCAD, but it's just so quickly convenient.
Yeah, so I meant to repeat the question the last time, but so I just mentioned OpenSCAD or OpenSCAD. I'm not sure which one, but so that's sort of a more programmable CAD option where it's directly scripting, and so with FreeCAD, this is something that's also possible. There's actually a Python interpreter in the program that as you click a button, for example, the corresponding Python command is shown in the interpreter, but the interpreter is not shown by default. And so it's also possible to record macros, essentially, of the Python commands that are being ran as you do things, and then replay them, or even just inspect what commands were being used in a particular workflow. But yeah, I'm glad you mentioned that because FreeCAD is not the only CAD option in open source. There are others, and it's really a rising tide lifting all boats type of situation where, for example, there is an OpenSCAD workbench in FreeCAD. And so people who like that sort of modeling approach can use that workbench to kind of pull the program into a workflow and come up with something that works for them.
Thanks, and thanks for all your work.
Thanks.
Okay. Do we have more questions for Kurt? One more here.
Nice.
I have more of a packaging question. You mentioned something about the snap being very customized. What exactly?
Well, so yeah, I think that's not. It's not that the snap is necessarily more customized, but that the changes that he is making introduce the potential risk of someone opening a file and that file being corrupted, for example. And so it's something where these changes, they need to be tested, but it has to be done in a way that is very easy to, let's say, switch from his stable branch to the tip of his code. And it has to be, like I mentioned, that's probably one of the main concerns with the adoption of his changes, is that we never want to have someone already have a FreeCAD file that they produced and then open it and it somehow either stop working completely or actually break the file if they were to save it. And so that's something that we had a major overhaul of the part design workbench in 0.17, and that was sort of something that happened occasionally for people who are like following the tip of FreeCAD. And so we want to be very careful to avoid that ever happening, because otherwise if people become burned by FreeCAD, it's kind of hard to get them back.
Okay, we have one more. We have enough time.
Just for interest, how long is your Snapcraft YAML? Or
How long has the Snapcraft been?
the definition file for the...
Well, so I'm not, I've only kind of dabbled in the actual maintenance of the Snap, so I can't answer, I'm sorry.
Okay, do you have, okay, right.
We're actually checked tutorials for FreeCAD. Are they
Yeah.
being rehauled or something? Because they seem very now you need to draw a wall, but they don't really say how to draw a wall and things like that.
So I didn't catch the last part of that.
Oh, the tutorials are pretty relaxed
Right.
in telling you what to do.
Oh yeah, yeah. It's something I didn't mention, but I originally found FreeCAD around 2012, and so it's been really interesting seeing the huge changes, and that's one aspect where the importance of tutorials and showing people how to actually get onboarded is important.
Okay. Do we see any other question? We are good. Okay.
All right.
So thank you, Kate, again.
Thank
Yeah, we have.
Thank you.
We now have 7 minutes before our next talk, so socialize, take a break, walk around, do anything you want. Okay, we start in just a few seconds time. Okay, welcome back. Our next speaker is John Seeger. He is the Vice President of Engineering, responsible for enterprise solutions at Canonical. Part of the teams that he leads are the teams that deliver Juju, and that's what he'll be speaking about today. Interestingly, also, he was part of the British Army, doing some interesting stuff there. He is a father, a husband. He loves coffee. He loves cars and motorbikes. So, yes, so thank you, and help me welcome him.
Okay, are we on? I think we're on. All right, so I'm going to talk a little bit today about Juju, what Juju is, but more fundamentally why we're doing it and why I think the approach that we're taking is a little more sustainable to some other people who are solving similar problems. So firstly, I think a little bit of context. Open source has kind of become the new mainstream in a lot of technology, right? So whereas 20, 30 years ago, it was kind of this weird little thing on the side that no one really talked about, and it seeming like no one seriously really used it. Now you see kind of big companies, individuals, you see as many people, like more people than we've ever seen before, contributing their code, their applications to open source. And it's not just hobby projects, right? It's like world-class applications in just about every category of software you can think of. Think of Linux for one, but Postgres, Visual Studio Code. There's just a huge like litany of ridiculously successful open source projects. And that has kind of made software really available, except that even with all of that availability, you still have to find a way to compose that software together. Most kind of enterprise software or software that needs to be operated in production in some way doesn't normally stand alone. You're normally going to need some kind of backing database, some kind of cache, perhaps a message bus. There's a huge kind of integration problem that you have, and that's hard enough when you just do it on one single cloud, but it's borderline impossible when you're doing it across multiple clouds all at the same time. You can obviously figure out how to do all these things in isolation, configure your Grafana to talk to this and your Prometheus to that, but every single application that you integrate with is going to have kind of a different set of patterns, configuration file formats, perhaps there are differences per cloud. And then even if you've done that, you then have to somehow support all of that and operate it, right? Like you have to take the automation that you wrote and maintain it. You need to keep dependencies up to date as new formats emerge, like OpenTelemetry, for example. You have to figure out how to evolve your configuration and then kind of roll it out over time. Let alone just thinking about your responsibilities to kind of patch your infrastructure and keep things up to date. So you might be wondering, well, isn't this already solved? Like there's all these big hitters on the screen that I've heard from: Ansible, Terraform, Puppet, Chef, Helm, right? Like all of these popular projects that you kind of see hanging around in Git repositories, right? You'll see Helm charts and Ansible playbooks and Terraform declarations everywhere. And I would say it's kind of a solved project, right? Like what all of these guys do really well is deployment. Right, like standing up a Kate's pod, put a couple of containers in it, or deploying a virtual machine, creating a VPC. Like you can do that stuff, but then what about backing up your apps, right? Let's say you've got 5 apps in production. You have to figure out a backup strategy for all of them. They're all going to behave completely differently. They're going to have different storage backends. How do you collect metrics from each of those applications? What are the important metrics? How do you build dashboards? And how do you then maintain all of this stuff, right? Like, one thing that's almost certainly true about all of these things is that over time your Ansible playbooks will rot, your Terraform kind of declarations will rot because AWS update their APIs, they change how things are provisioned, they change the SKUs. And so while some of these are very, very competent tools, of which I'm very supportive, we have a Terraform provider for Juju, they don't really solve the whole problem, in my opinion. Or at least not without a significant amount of toil and kind of wraparound alongside. And so, as I was kind of saying, we've got all this open source application code, but that hasn't really helped enterprises actually adopt and use that code, right? Like, without a solid understanding of how to operate the applications, how to back them up, how to patch them, there's often just too much perceived risk, particularly in your kind of more traditional enterprises. And so they end up not really being able to take advantage of it. And so what we really need to do is get to a point where people aren't just open sourcing their applications, but they actually open source the operations code too. And what is operations code? Like, what is it we'd be looking for people to actually open source there? Well, it's all of the domain knowledge that the people who wrote that application have about how to drive a Postgres in production, right? How to set up a set of Prometheus scrapers, how to, whatever the application is, the people who wrote it or the people that built it are likely to understand how best to configure that in various situations. And if you can kind of condense all of that down into some clean, well-tested code and share that, then the chances of businesses and individuals being able to actually wield your software in production go up quite dramatically. And so that's kind of what we're trying to do with charmed operators, right? Charmed operators are packaged ops code, simply, right? It's packaged ops code with a mechanism for distribution through a store, and then a kind of lifecycle manager, which is Juju, to kind of pick them up and deploy them wherever it is you need them. So I guess I'm presenting Juju as a platform for you to deploy any application at any scale on any platform or substrate, any architecture, right? Like, you can, in theory, and in many cases in practice, rely on Juju to do all of the things we've just been speaking about, alongside the kind of ecosystem of charmed operators. And we're going to kind of spend a bit of time trying to understand what that means. That's interesting. There's supposed to be little Juju symbols along that line, but I don't know where they've gone. I can see them on there and not on there. But anyway, so at deploy time then, what does Juju do? Well, it behaves just quite similarly to Ansible or Terraform, right? It's going to go and pluck you a VM from OpenStack or from AWS, or it's going to deploy a Kates pod with a couple of containers in it. And it's going to maybe run some scripts or some kind of predefined actions to install packages, write configuration files, start and stop services, whatever it might be, whatever is kind of idiomatic on the platform that you're on. And critically, all of that integration is maintained by the Juju team, right? So there's 22 headcount or so at Canonical, full-time people to work on Juju, making sure that the latest and greatest AWS APIs are supported or Azure APIs are supported. But the really important bit, or the really interesting bit, is integration here, right? And so Juju provides this kind of rich language for joining applications together and sharing information between them, which we know as relations. And fundamentally, because we're open sourcing all of the operations code, you also get to see exactly what's going backwards and forwards between these apps, and therefore what you would need to do to make them talk together. And on the operations front, there's another kind of rich set of languages for running actions at day 2, which might be triggering a backup or upgrading a package or kind of refreshing the thing from the store. There's all this kind of stuff that you might want to do, 2 days, 10 days, 5,000 days after deploying your thing. That's kind of all built into Juju. So when we talk about software lifecycle, what are the sorts of things we're talking about? Well, at deploy time, you're talking about installation of packages and software. You're talking about configuration of that. You may be talking about upgrade of operating system components. You may be talking about deploying at some particular scale. As we talk about integrations, well, you've got databases, observability tools, caches, event queues, like whatever it is. And in operations, there's some kind of contrived examples up there of the sorts of things you can do, but really it's anything that you might want to do after the fact where you've initially deployed the software, right? So another really interesting feature about Juju is kind of how flexible it is. So in this example here, there's 4 kind of scenarios, right? And you can use Juju to build any of these. So on the far left, you have AWS, on top of which you could deploy charmed Kubernetes, composed of a bunch of AWS VMs, and on top of that, you could deploy Prometheus, Postgres, and Kafka, which is a sort of contrived, somewhat unrealistic stack, but you can deploy that on top of the Kubernetes that you just deployed on top of AWS. You could also start with a bare metal deployment, right? You start with MAS, you put OpenStack on top of MAS, then you use the same Juju controller to put Kubernetes on top of that, and then you use the same Juju controller to deploy your apps on top of the Kubernetes. Or you could just go straight to Azure, for example, and deploy these apps as VMs directly on Azure, or you could go to any kind of conformant CNCF Kubernetes and deploy the app straight on top of that. And the interesting thing here is you can use one controller for each of these stacks, or you can use one controller for all of them combined, or you can have a whole bunch of controllers up and down the stack depending on how you break down your business, how you kind of break down responsibilities for who has to support things, deploy things, configure things. It also gets probably the closest I've seen to the argument that you can write your code once and deploy it anywhere. Terraform famously came out with this, right? They said, well, it's easy. Just like write all of your infrastructure down as Terraform code, commit it into version control, you can put it anywhere. Except what they really meant is you can put it where you meant to put it the first time. But if you need to move to Azure, you get to start again, right? And then if you want to move to Google Cloud, you start again. Because all of the services are constantly changing and the SKUs are different enough that there's no real universal language between the major public clouds and private clouds, right? With Juju, that's actually not the case. With Juju, we have a Postgres operator which you can deploy on all of the major public clouds, and there's one extra variant for Kubernetes which shares a whole bunch of code. And so you do actually become sort of empowered to just pick the cloud provider which has the best resources for your particular workload. Perhaps it's the best cost breakdown. Perhaps there's a better support relationship with your organization and that changes over time. Whatever it is, you can just take whichever workload you had deployed and move it to any of the supported clouds. And provided the charmers are doing their job properly, then you should have all of the facility you need to move data between clouds and essentially move from one provider to the other without having to re-engineer your entire infrastructure, right? It's fundamentally possible for you to pick up the exact same code and drop it on a different cloud. It also, alongside the kind of basic integrations that you can do, so you say you've got two things on AWS, a Postgres and some web application, well, you can make those things talk, but you can also do it across cloud, and that's across private cloud and public cloud. One of the things that we don't do right now is actually establish the connectivity for you, so there's a kind of a bit of an assumption there that you'll need some connectivity between your AWS tenant and your Kubernetes cluster on-prem, but once you have that, the relation system works fundamentally exactly the same. So if you want to run your database on bare metal in your data center, but you want to be able to scale your front end out to level ridiculous on Kubernetes on AWS somewhere, you can totally do that. And if you want to change your mind down the line, that's kind of also fine. And we've got a way now to distribute these kind of relations as little tiny libraries that anyone can put in their code, right? So as the ecosystem starts to grow out and more people are contributing to things like MySQL and Postgres and Redis and Grafana, the toil for individual businesses to then charm their applications and make use of those things is really, really low. You're talking maybe 50 to 100 lines of Python to basically stand up an application. You go and grab a library because you need to speak to MySQL, add a couple of lines into your charm code, and then it can speak to MySQL anywhere Juju understands MySQL, which means you can kind of empower your developers, your users, to be anywhere they need to be. And a recent example of this was with Charmed Magma, which is a project that was originally started by Facebook for building 5G core networks. It's comprised of 50 or so microservices in total, and their documentation and all of their automation worked just great on AWS. Like you could deploy the thing on EKS, no problem, but there was absolutely no mention of how to do it any other way. We've written some charms for that in about 8 months in total, and now you can put it on any of the public clouds you want, or you can just host it in your data center. And it's all the same packages wherever you do that. Right? So Juju kind of has allowed projects like Magma and will allow other projects to kind of diversify their audience quite dramatically. So we are slowly building out a catalog of what I think are pretty great applications. It's almost impossible that there isn't going to be an application up there that you don't recognize, if not more. And to me, these are kind of foundational pieces, right? There are going to be so many applications that require MySQL, that require Postgres, Redis, OpenSearch, Grafana, right? These are kind of like table stakes things that you're going to need. If you think about a public cloud with things like Cosmos DB and Amazon RDS, these are all the reason Amazon has been so successful there is because everybody needs a database for their thing, right? And so Canonical has committed to essentially building out teams for building and maintaining these foundational pieces completely in the open. It's open source, so other people can contribute and add features and changes if they wish. But fundamentally, the building blocks are all there for people to go out and deploy their own big, complicated distributed systems in whichever manner they want. And I think a general principle when building charms is to think about building charms that are really, really great on their own, but actually better when composed with other things, right? That's kind of the whole problem we're trying to solve. It's not about deploying individual applications, it's about composing them, to build up stacks. And so if you think about some of the products that we're investing in, Kubeflow, for example, is 35-something microservices on Kubernetes. Our observability stack composes things like Grafana, Loki, Prometheus, Alert Manager, and Magma I already talked about is for building 5G core networks. These are essentially bundles that take the task that was kind of spend an hour, spend 2 hours, spend 5 days, trawling through documentation, trying to troubleshoot this thing on this one particular cloud to get your deployment working, only to realize that something fell over and you have to start again on a different cloud and you don't know how to do it over there now. All of that simplified in this case to Juju deploy Kubeflow or Juju deploy Magma, wherever it is that you've got a Kubernetes or some sort of infrastructure provider. And that's actually kind of just the beginning of this story. So bundles are what we have now. Things are slowly kind of evolving towards a thing called stacks, which are kind of a nicer abstraction for managing collections of software and kind of more complex software. And I'll cover that a little bit later on in my talk about kind of development work that's going to happen in Juju over the next couple of years. So I would say hopefully obviously, but all of this is open source, so you can get the code for Juju on GitHub if you're brave enough. It's a big old beast. There's also Pebble, which is this kind of tiny little init system that has been written specifically for this use case, for managing workloads on Kubernetes. It's kind of our little superpower for how we choose to drive applications on Kubernetes. The Charm Hub itself is open source. You can kind of head over to the Charm Hub and see all the charms we have available in the catalog. It kind of presents the information about configuration and day 2 actions and documentation all in one place. And then we have the operator framework, which is our kind of developer-facing toolkit for actually building charms. So if you want to write a charm for MySQL or for whatever it is, you would use the operator framework, which is a kind of nice, tight Python library that is kind of based on the event model. So essentially, Juju will fire events to your application at various times in its life, and you essentially attach callbacks to that and do whatever it is you need to do with your application. So all of that is on GitHub. It's all there for you to see. We have increasingly got quite a nice community presence. So the Charm Hub, as I mentioned, is the store, but it's also host to a discourse forum. So that's where you can interact with the various store maintainers for maintenance done on your listings on Charm Hub, but also just asking for advice, interacting with the various Juju developers, a good number of which are sat in this room. And then if kind of a more real-time chat is your thing, then we have a Mattermost instance, which anyone can sign up to, and most of that team and most of our Charm teams are in that instance all of the time, right? So if you have questions about charming, questions about how to wield some of our other charms, database charms, etc., troubleshooting, then people are there to be on hand and also kind of guide you towards your own charming efforts. We also have a public roadmap. It's probably a couple of days out of date. We've just done a bunch of planning, but I'll get on that over the next few days. And that's how you can track upcoming work on Pebble, on Juju, on the operator framework, on a few other things. And it's kind of a distillation of our internal roadmap. And because it's on Trello, if you wish, you can kind of comment on it, ask us questions, vote for things, etc. And that kind of all gets taken into consideration as we go through the various rounds of planning. That is all I had for the basic introduction to Juju and model-driven operations. Is a bit of a canter through, but we've got a little bit of time for questions if anybody has any. Ideally, those people who don't work in the Juju team. So yeah, thanks very much.
Thank you, John. Okay, do we have some questions for John?
Easy.
Hello.
Hey.
My question is, I've been using UE for quite a while, and I get the feeling sometimes that it gets more and more Kubernetes focused somehow. Does machine charms have a future?
Yeah, so machine charms absolutely have a future. They're not going away. It's definitely true that there's been more investment in Kubernetes over the last couple of years because broadly in the world there has been more investment in Kubernetes in the last couple of years, and if we ignore that, then we kind of eliminate a huge part of the market. One of the things that I'm quite excited about is taking some of the work that we've done there, so integrating Pebble and kind of the way that we think about modeling charms and bringing that to the machine world. So I'm hoping that we'll get to a point where we have these sort of universal charms, and universal charms will potentially be OCI image-based, so when you deploy to a machine, what you're actually getting is a couple of OCI containers stood up on container D, sort of behaving in the same way. That said, the kind of hook tools in Juju aren't going anywhere. So like first-class machine charms, as you know them today, are not going away. There's absolutely no plans to stop that. But it will give us an opportunity for people who have invested in container-based charms to also deploy them in kind of bare metal environments and that kind of thing.
Yeah, great, thank you. Because we love machine charms.
Okay, do we have more questions?
Really nice talk. Thanks for that. It's really exciting to see the integration and kind of the growth around Kubernetes and how Juju service orchestration kind of fits on top of that. How did your team develop these technologies, like let's say the mini Kubernetes execution utility, Pebble? Where did this come from? How did these things come about?
So Pebble's an interesting example, right, of why Juju development can be hard, right? So one of the things that the Juju team, I think, does quite a good job of, and has historically done quite a good job of, is we make this promise, right, that everything that you can do on AWS, you can do on bare metal, you can do on K8s, you can do on Azure, you can do on whatever it is. And that means there's kind of a responsibility upon us to only build abstractions into Juju that make sense in all those places, which is why support in some places might seem a bit patchy, right? So there'll be no doubt people in the room who could jump up and down and say, but you haven't given me daemon sets yet on Kubernetes. And the answer is no, we haven't yet given people daemon sets natively, because we need to find a way to kind of convey that intent in all of the different environments that we work in, right? So Pebble is an example of that. Pebble was a way of us allowing people the freedom to deploy whatever OCI images they wanted using Juju on Kubernetes, but maintain the kind of same mental model that they had about how charms worked and how to reason about them, right? So it was actually the kind of second iteration of Kubernetes support when we got there, but I think it has led to a much more consistent view for people who, for example, have been using Juju for kind of several years. The way that we now model charms and think about charms on Kubernetes should feel very familiar, right? Like there's not a lot of difference. So yes, I think that's a long-winded way of saying it's all about trying to achieve that consistency so that we can actually keep that promise of portability across the different clouds and substrates and that kind of thing.
That's really exciting. Thank you.
Okay, one more question. If you have a question, you can always raise your hand up early, then we'll just bring the mic to you earlier.
Okay, so Juju API access, RESTful API is available now, or?
There isn't a RESTful API. The Juju has this like JSON RPC over WebSockets game going on. There is a Python client library called Python libjuju, which is pretty well developed. There's a whole bunch of charm teams that use that all day, every day for testing their stuff. Typically, or traditionally, I'd say we've done a kind of less than excellent job of keeping the Go kind of library code decoupled from the CLI, but there's been an ongoing effort in the last cycle and in the next 6 months to kind of pull that code out and kind of untangle it from the CLI code into something that resembles kind of like a Go libjuju. If you don't want to use Python and you don't want to use Go, there is also kind of an API like schema that gets published with every release. And I think the general kind of Juju API will be a topic of discussion in the future, but there's a bunch of other really big stuff we're working on at the moment that I don't want to kind of tackle at the same time as changing how the API works, if that makes sense.
And is the Go library still using the WebSocket? Because what we found is the WebSocket, if it gets broken, then the whole API command is then orphaned. And
it is still using WebSockets, yes. If you've got questions about that, there's like half of the Juju team in the front couple of rows who'll be able to help you out.
Employee of Grafana Labs, so it's really cool to see you packaging a Grafana bundle. I'll definitely tell the team, and I'm sure they'll be really excited. I don't know if you work with anyone at the company, but yeah, I'll pass that on. I'm sure they'll love that. Just for information, we use JSONit to render Kubernetes manifests and then deploy those with Flux. So my question's kind of related to that. What kind of do you support any as code workflows with Juju? So is it possible for us, for the room, is it possible for us to write down a kind of our desired state and have that rendered through Juju into our let's say Kubernetes clusters, but it could be anything.
Yeah, so there's a couple of different ways you can achieve this. So Juju doesn't necessarily fit into your traditional, like, all declarative, like, I want a JSON file that exactly represents state. And I think we would be kind of degrading some of its value if we went too far down that route, because kind of the whole point is an acknowledgement that things will change over time, right? That's what operating software is about. That said, we have got a Terraform provider for Juju now, which, and the whole point of that is precisely to enable this kind of workflow, right? So the Terraform provider can create models, deploy charms, config charms, create relations, create cross-model relations, and it's clever enough to be able to, like, when Terraform does its state reconciliation each time you plan, like, it can go and query the Juju API and figure out what the differences are and allow you to make choices. So that's probably the closest we've got, and I think the thinking about that and kind of the development of that would enable us to go and do things like Pulumi integrations, for example, if people desperately wanted to write ops code with JavaScript or something weird. But yes, and yes, the Grafana folks sort of do know what we're up to. Our observability team lead is an ex-Grafana employee too, so there's quite nice links there.
Okay, do you have any more questions? All right, thank you again, John.
Cool, thanks very much.
Okay, so we go for tea break now, and then we'll be back at 4 p.m. for our next talk.
Czech Republic. 1, 2. No, no, give me one. Can you hear me? Yes. And what if I put it here? No. Have to say here. Okay, have to keep it here. Nice. Check. Here is too low. Here is no. Here.
Okay, welcome back, welcome back. We start in just a few seconds. Right, welcome back again to our session. Our next speaker is Gabriel Nori. Sorry, I want to say your middle name because I don't want to butcher it. Gabriel is a product manager at Canonical. He has a PhD in robotics. He is very passionate about health, providing robotic solutions in health. He has a lot of siblings, but he loves Felipe, his last born, their last born. Funny enough, I was trying to get familiar with my speakers and I stalked them, but I found nothing but robotics on all his social media platforms, so I had to have some socializing with him. He is going to speak to us about open source in robotics. So take the floor and help me welcome him, please, everyone.
Thank you, Jessica. I really appreciate that intro. Just building on that point, when you come from a big family, a lot of the passion of certain technologies develop thanks to the involvement with them, thanks to the involvement with your brothers and so on. So yeah, I really appreciate coming from a big family. Welcome all. Today we're going to be talking about open source and robotics in this chat. This is more to celebrate your activity. As a community, today you have been already contributing, and I'm going to show you how you are key to that success in robotics. I also want to say hi to everybody that is following us live. And one of the things that I'm not going to say but I enjoy during COVID time was the fact that when you were invited to give a presentation, you were talking to a screen. So you didn't have to worry about, I'm talking with 100 people or 500 people. No, it was okay. You were talking to a screen. The social pressure was taken out of the equation. It was just me and my laptop. And while this concept might be trivial or even vague for some of you, it plays a fundamental role in what is human-robot interactions. Just like my laptop, it is easier for people to talk with robots. Several studies have shown us that we feel more comfortable talking with them, sharing how we feel, sharing our struggles, our fears, our dreams. We feel safer, just like when you give a presentation to your laptop. But robots can do much more than what a PC can do. Robots have unlocked in healthcare new models for treatment, improving patient cares, improving the response time, giving up more time to the healthcare professionals. I really like talking about this company. The name is Lika. It's a French startup that 5 years ago started a journey of helping children with autism. So the idea is that for children with autism, it's difficult to read the facial expressions of people, if they're happy, if they're angry or not. Robots can help you train them, can help them learn about these things. But robots can do much more than just that. They can also be helping us right now in agriculture, making things more sustainable, reducing waste. They are also helping us today delivering medicines in difficult regions, in cities where getting there by car is almost impossible. And they also help us cooking. And all of these examples are real. The last one, if you were wondering, is called Motley Robotics, and it will help you cook better food. And at the same time, the technology keeps evolving. Today, we see quadruped robots that are capable of standing in 2 legs and walk. Modular architectures that can shift an assembly to help them conduct certain activities. We also find small micro robots capable of navigating through our blood veins, and also some robots that play football, because Why not? And here is what I was telling you at the beginning. One of the reasons that we have all of this is because of you. If you ever contributed to Ubuntu, by advocacy or a technical contribution, give yourself a pat in the back, because a lot of these things were achieved thanks to you, to your contributions, and thanks to all the work that we're doing here together. Today we will explore how open source became the de facto for robotics development, how they built that community, how you can learn what they did so you can apply to your projects, and again, how you're already part of it. So, a little of history. Back in those days, we go back to the 70s, to the 80s. For a long time, you will get your hands on a robot, and the first thing that you needed to do was to write a lot of what we called infrastructure software. You needed to spend months building complex robotic software infrastructure, basically drivers to the sensors and actuators, as you can see, and communication between different programs inside the same robot. And that was just to make the robot basically work, to do the basic things. We were building these machines with the only concern on the hardware and the low-level embedded software that drives it. For example, you develop your single Python script for controlling the motors, reading from the line detectors, reading from the ultrasonic sensors. All of that takes time. You did it from scratch, despite using the same sensors as others. Then what if you throw a wireless controller into that mix? As you can see, all of that script quickly gets more complicated. And if you wanted to, for instance, benchmark a different sensor, you needed to rewrite the whole thing. So we were pursuing these monolithic architectures and reinventing the wheel along the way. Another of the challenges that we were having is that we didn't have any of these key robotic applications. So if I wanted, for instance, my robot to move around, to do some navigation, I needed to develop that algorithm from scratch. If I wanted my robot to do some manipulation, I have to develop the algorithm for perception, for object manipulation, all from scratch. We didn't have any tools for visualization of data, for debugging, or even for simulation. All of this was either proprietary and for a specific robot with a specific set of sensors. Just think about that. 12 years ago, we didn't have any of these widely available. But despite that, today, we have all of those robotics examples that I show you, and that is crazy. And only then, after you build your infrastructure, after you build your tooling, you could actually do some robotics research, do an experiment, solve a problem, test an hypothesis. Too little time was dedicated to actually building intelligent robotics programs. That picture is from a really famous slide made by Eric and Keenan back in the early 2000s. It's not mine. They were robotics researchers at Stanford that decided to stop this madness. Back in the, sorry. Can we play the video? No. Okay, so they decided to stop this. And in 2006, they started a program called Stanford Personal Robotics Program. And this was a milestone for what we have today. Their aim was to build a framework that allowed processes to communicate between each other, plus some tools to help create code on top of that. A first step towards a middleware. And they implemented that in that robot that you can see there, called PR1, Personal Robot 1. The framework will eventually be called ROS, Robot Operating System. Despite the name, ROS is not an operating system. ROS is a middleware. It's a set of tools and libraries that allow us to have low-level device control, hardware abstraction, and communication with processes. So, ROS allows developers to adopt this modular architecture, sharing, reusing code, and reducing infrastructure development time. So our monolithic application, now it looks like this. In essence, what ROS is doing is introducing a standard message for certain kinds of data through what we call ROS core packages. Each node that you see in the picture sends and receives data messages over a topic, distance, velocity, and so on. Therefore, now my sensor or actuator could be used in any other robot as long as it provides the same standard message structure. So for example, if you wanted to switch your LiDAR sensor and regrind, for instance, the distance sensor, the distance module, you could do that without having to touch any of the other components. It no longer matters if your distance sensor was connected by serial, Ethernet, or USB. If the ROS package was available for that specific sensor, it can interact with your whole structure. Everything was getting more standardized. In the same way, they start adding those tools that we were mentioning about visualization, for debugging, recording data, orchestration of services, and more. And a key milestone was achieved in 2010 with the integration of Gazebo, a simulation tool that was not even part of the ROS project in those days. Was part of the player stage project. In a way, it was a competitor to ROS back in the 2005, around those years. But they decided to take this Gazebo simulation tool that was having success in that ecosystem and bring it to ROS. So after 4 years of hard work, in 2010, they released the first general distribution of ROS, Box Turtle, on top of Ubuntu Hardy. So like many other open source projects, they pick up Ubuntu due to all the benefits that you love and you enjoy every single day. And since that first release, our synergy started. It's running? Yes, it's running. For the past decade, ROS has been natively supported in Ubuntu. So let me give you a little bit of context of that, of what we do. Every single LTS release of Ubuntu comes with a ROS LTS release, which means that every single time that there's going to be a new ROS LTS, we work with Open Robotics to be sure that there's all the ROS packages needed on Ubuntu before deploying that. Open Robotics is the maintainer of ROS. And today, Jellyfish and a Hawksbill Turtle are working together with the release of Ubuntu 22.4 and ROS 2 Humble Hawksbill. But we are jumping ahead of time. First, ROS needed to face several challenges as they start building a community. Just like you, just like me when I had my own project, there's no community that is backing you up. Therefore, you have to start building the community, and that's where they were facing. Putting up a community is a hard work. If you don't believe me, you can ask our wonderful support team and all the time that they have spent putting and setting up this wonderful stage, this wonderful event. So during that time, many other frameworks were also available. URVI, Player Stage, Microsoft Robotics Developer Studio, which is that one. That's how it looked. They were trying to build their ROS. But none of these were a success. One of the main reasons was because they failed to build a community. Some of them went through the path of licensing. Some of them went through the path of you have to pay for this service. Making it open source was the first right decision of ROS. Another key decision was taken with the release of the Personal Robot 2. It's already on screen? Yes. And this was a robot that became a test bed for the framework. So Keenan and Eric, now working with Scott Hassan, investor and founder of Willow Garage, decided to build 10 of these robots and provide them to universities. So students, researchers can start using that framework that they created. The price of that robot was $400,000, 400K. So you can imagine yourself driving a startup, pushing those costs, trying to push a new framework that no one has used it before. They were under a lot of pressure to make that work. It's incredible. So now under this umbrella of Willow Garage, ROS started running different initiatives to help more robotics researchers get into the ROS framework. And to do that, one of the best initiatives that they took was their internship program. So between 2007 and 2013, 140 students, 140 interns came through Willow Garage. These interns, they became the spread vector of the ROS pandemic. And they also provided a lot of libraries that were desperately needed by the robotics community around the world, now with an open source license. Today, as some of you will know, we have thousands of ROS packages to help you reduce development time. What it used to take us 1 year of work and a fully fledged robotics team, today can be easily done in 3 months and 1 engineer time to develop a prototype, a simple prototype. And that is thanks to these community contributions. For instance, TF2, a transform library for robotics, lets user keep track of multiple coordinate frameworks. So you have a robotic arm, you have different joints. If I'm moving this joint 30 degrees, this joint 60, and this other joint 90, where is going to be my end effector? All of this is complex math, but it was hard work that you needed to always do as you change from different robots. Now there's different mathematical libraries that are available for you to use. The same with the Unified Robot Description Format, URDF, that allows you to create an XML file that describes the joins and links of your robot. So now you can take that and describe how your robot should be represented in a simulation environment. That has been standardized now. So you don't have a problem taking the robot that was developed in, let's say, Colombia, and combine that with your development environment that you have in Germany. And all the messages, standardization interfaces for sensor, geometry, and graph. ROS, this framework made it possible to reuse all of that. And again, this started running 10 years ago. So what we have achieved is an incremental growth in the number of ROS users, where a lot of effort was put into also documentation, improving the documentation, following stable releases processes, add channels for people to ask questions, or even organize community events like the ones that we're doing today, allowing people not only here, but also live to join us. And the community start growing because of that. They saw the work and they start joining the ROS community. And the same should apply to your projects. The same should apply to your startups. The same should apply to every initiative that you're trying to build. You have to do the extra work for others to take your project and push it as well as you are. So, ROS right now is everywhere. This slide is from Open Robotics, and it's describing what you find right now in the autonomous mobile robot sector. So these are robots that are widely used on warehouses. That is the main market for ROS and one of the main markets for robotics besides industrial robotic arms. So we're talking about warehouse, for instance, in Amazon, moving different boxes, moving equipment and resources from point A to point B autonomously. And what you see here is the acquisition of some of these companies. So let's take the one on the top right, Fetch. Fetch was a ROS startup that started more than 6, 7 years ago, a long time ago, with one of the ROS, the CEO of the company was one of the people working in Willow Garage. And they were able to sell Fetch Robotics to Zebra for that amount of money. Amazon have acquired Canvas, the one that we don't know for how much, and so on. So you start seeing that today we're in that stage where all the exceptional unicorns that we have for ROS startups are being acquired by big international companies. The same analogy will apply to robots that are delivering goods and services. Some interesting companies, KiwiBots, Prime, Robotics, that is going through that journey as well of deploying their own robots in that sector. Yes, we might not see some of them in our daily lives. In some areas in the US where the regulation allows, we can see them more often. But nevertheless, this is another market that in the next 5 to 10 years is going to boom, especially because at the end of the day, it's taking the technology from warehouses and applying that technology to hospitality, to healthcare, to offices, to delivering normal day goods. Another sector that is well developed is agriculture. Big companies such as John Deere has been doing a lot of acquisitions of ROS startups, and that is just going to continue. With the development of this sector, like we were saying at the beginning, we're going to a path of more sustainable farming, more sustainable delivery of food to the world in order to reduce waste. So a lot of work that is being done in autonomous tractors is being right now trying to be pushed into that industry. Something that you have to remember is that in these sectors, there's no the same strict safety regulation that you have to provide with autonomous vehicles. These are controlled environments, therefore it's much easier to have an autonomous tractor without someone driving that, okay? And of course, we go to autonomous vehicles. If you've been following robotics for a long time, you know that in 2008, one of the first DARPA projects is the first time that ROS was used in one of DARPA missions. And since then, the companies that we have seen, companies that have made spin-outs of Google and so on, are ROS users. And Apex AI, the one on the top right, is another framework for you to develop these autonomous mobile applications based on ROS. Apex AI is one of the first organizations that I know that was able to go through a certification process of the ISO, if I'm not wrong, 26262, and certifies ROS modules, certifies an open source project. They did that after a lot of work, 3 years of work, going line by line and being sure that those modules were written according to the specification of the certification, which is a lot of work, so a big congratulations to Apex AI for doing that. And AutoWare, another project that builds on top of ROS, open source, that allows you to get access to simulation tools, to get access to autonomous navigation algorithms, and other tools for you to deploy autonomous vehicles. So, today is expected that in 2024, we will have around 13.5 million of robots running ROS. And that is a huge number. And with ROS, we also expect to have Ubuntu deployment increase. These are some of the interested robots that I wanted to share to you today that are running Ubuntu and are running ROS. And so, like we were saying, autonomous mobile robots for warehouses, roughly 90% of those are running Ubuntu and are running ROS. And the same in autonomous mobile vehicles. I don't know if you have noticed that project of Indy cars, autonomous driven cars that are going at incredible speeds, competing between each other as well, so they overtake each other without a pilot there. It's amazing that we are able to do that now today. In the middle, you see everything that is cobots. That is the new robots that we will have in the industrial sector that will allow you to have a robot in a working space. So no longer we will need to have cages around a robot. We can have people working closely together with the robotic arm. We have also our quadruped robots helping and reaching more industries. That one is also running Ubuntu and ROS. And we also find NASA deploying robots to space to help astronauts, that one there, face isolation in space. So when they don't have people to talk with in space, they can talk to the robot in the same way that I was talking to my screen when we were in the pandemic giving presentations. So our responsibility and commitment to this community will keep growing. This is what we are bringing today to the robotics ecosystem. A whole infrastructure for them to fill the next gap. The next gap that is software deployment. robotics companies today, they find themselves in a tricky situation where they have to deploy, where they have to maintain software. They find themselves doing the job of many ISVs. And therefore, they are spending resources, they are hiring people to take care of that. But doing that doesn't help you build better robots, doesn't help you improve your hardware, doesn't help you improve features, just takes time from you and takes money out of you as well. On the other hand, Canonical has been doing this for a long time. We deploy Ubuntu to millions of users, we make that available, and we update that every single time. So what we want to do for the robotics community is provide you with the same infrastructure. So you love developing with Ubuntu, then you can deploy it with the snaps and on top of Ubuntu Core. So probably you have heard snaps a lot inside the context of desktop. In my opinion, snaps, they shine the most in embedded applications because they allow you to do all of this without you having to set up new infrastructure. If you want to standardize different channels as beta, experimental, stable for your customers, you already have that. If your robot is being updated on the field and for some reason someone plugs off the robot, there's no longer power, the robot, when it boots again, is not going to be broken. It's going to jump to the previous version of that application. You have Delta updates, so when you have software, when you have a robot that is really far away with a poor internet connection, thanks to the Delta updates, is only going to install those binaries that change between the previous and the current version. Setting up all of that infrastructure is the equivalent of reinventing the wheel. It's the equivalent of making those mistakes that we were doing in the 80s, in the 90s, where we didn't have that open source community around robotics. And as we saw that many people were deploying Ubuntu Desktop and Ubuntu Server with their robots, we decided to create something better for them. Ubuntu Desktop, Ubuntu Server is in the name. Desktop is for desktop, server is for servers. Ubuntu Core is something that we created for embedded devices, for IoT devices, for robotics. And the great benefit is that at the back of it, it comes with all this set of features that you don't have to, again, integrate, that you don't have to maintain. Things as secure boot, full disk encryption, the minimal image as well. Ubuntu Core is in size reduced image compared to Ubuntu Desktop and even to Ubuntu Server because you only have the bits that you actually need. So for instance, if you are using the Raspberry Pi, you don't have to install the full Ubuntu Desktop image that contains some things that you actually don't need to deploy your devices. Ubuntu Core comes with essential things for you to run your applications that are running as snaps. Plus the 10 years of security commitment. Developing a robot takes more than 3 years to come up with a minimal viable prototype, and then to go to market, let's say 4 years. So after 4 years, you are just close to 1 year of being end of life, because that is the time of a LTS release of Ubuntu. That is the time of the LTSs of ROS as well. Working with Ubuntu Core, you get 10 years of security maintenance. So that device that you're putting on the field, you can tell your user that the OS, the kernel, the base layer, is going to be maintained by 10 years. Okay. And I see that I went too fast with the time, but well, that's how it is. I want to finish with this question. Where to start? I got this question during an interview in Roscon. If you are new here to robotics and you want to start in this field, but you think that you need to study robotics or mechanics or electronics or have a PhD in robotics, that is not true. Like I was saying at the beginning, you are already contributing if you're contributing to Ubuntu. And the field of robotics is so big, that it touches so many different fields. That robot there, probably you have seen the videos, right? That robot there is running Ubuntu. And for developing that robot and for making that robot successful, Of course, you need people that know mechanics. Of course, you need people that knows electronics. But you also need people that knows about psychology in order for them to develop a robot that will actually have a meaningful interaction with the people. You also need people that know about marketing, because at the end of the day, the robot is going to say things. And if it doesn't say the correct things, the people are not going to adopt it. You also need to develop robots that look appealing, so you need design skills. The only thing that you need to become a roboticist is the passion. That's it. If you have any questions about anything, please, now is the right moment to ask them.
So much, Gabriel. Okay, what an interesting talk. We have a question here.
Hey, thank you for your presentation. If we want to run Humble on Mi Pepper, which is better, Ubuntu Core or Ubuntu 22 version? Thank you.
I'm not sure if I understood correctly the question. If it was about a specific robot and running Ubuntu Core on that robot? Can you repeat the question one more time, please? Sorry.
We want to run Humble version on our Mini Pepper robot.
Okay.
So which Ubuntu version is you recommend? Ubuntu Core or Ubuntu 22?
Perfect.
Thank you.
Okay, that is a question more about Ubuntu Core. So, yeah. Ubuntu Core is this OS for deployment of embedded devices, IoT devices, and so on. The question is simple. If your robot is going to become a development platform, let's say I want people to hack into the robot. I want people to be able to break things around. I want them to be able to see the source codes of all my applications and so on. I want them to, be able to do anything they want to. Ubuntu Core is not for you. Then, of course, use Ubuntu Desktop, use Ubuntu Server. If, on the other hand, you are deploying a final application that you don't want your user to hack into. For instance, I don't want to deploy my warehouse robot and allow my user that, I don't know, by mistake, change something in the configuration, change something in my code, and by mistake, injure someone with one of my robots. I don't want that. Therefore, yes, I go with Snaps and Core. So think about that, and that's also a big difference of why we use Snaps. Snaps are for deploying final applications. Snaps are not for deploying code that you want someone to debug. Okay? Cool.
Thanks for the mind-blowing presentation. It was really great. Being ROS a kind of a standard, I'm pretty sure we're able to run that on other Linux platforms, but Ubuntu. In such case, what's the percentage of the market share you'd say we have nowadays, if it's possible to estimate?
I'm so sorry. Those mics are so difficult to understand what people are saying. Can you repeat one more time?
Yeah, I wonder about the market share of Ubuntu in the ROS ecosystem, because being a standard, I bet it's possible to run on other Linux platforms.
Cool. Good question. So, like I was showing you I'm returning to, sorry for the people that are following live. The question was about market share, market use, user use of Ubuntu inside the ROS ecosystem. So one of the slides that I show you, let me go back in time. That one. Perfect. Those has been most of the ROS releases until 2019. When they started the project, they started working with Ubuntu, and therefore they were testing on Ubuntu, and they were deploying those packages to be working right away on Ubuntu. And since then, they continue that trend. And like I was telling you, every release, we work together to be sure that ROS is going to be working even before they deploy ROS, they release ROS. So, as you can see, that also makes us kind of the preferred OS for running ROS. Every single time that there's a bug, they are testing it first on us. And they also have that ability to talk to us, to our engineer team, and say, hey, we have this issue, please can you fix it? And we try our best to be good with them and work as fast as possible because of the huge community. So yes, you are right. You can install ROS in more OSs, but we do all the work to keep people happy on Ubuntu. And that's why people stay and work with ROS in Ubuntu, and we hope that that is going to keep being the de facto for the industry.
Hey, I would like to ask a question. I'm thinking about maybe deploying my software as a manifest. So that means that I have a direct correlation between my backend server, my backend version, and my robot version. And in case I fail to deploy my app onto the robots, I'd like to have an option either for a rollback and maybe even notify the backend server that this is what I want to do and revert also the backend server, the backend version. So, sorry.
I'm so sorry, but it's super difficult to hear people. If you don't mind coming closer, because at the end of the day, you can, and you can ask me again the question, it will be easy for me to hear you. Thank you.
Well, the warehouse is a very, I would say, problematic environment in terms of I cannot update half of my robots, and I need to make sure that full maintainability with the backend version. Yes. And they are completely different things because I cannot ensure that everything was deployed correctly. How can I create manifests for making sure that I'm having a good rollback options, I'm completely synchronized with the versions, and if there's any problem, any error, the backend will know about it as well and also will block the update?
That's a good question. It's a question about the nature of the challenges that robotics companies have to face on that specific sector that is warehouses, and it's true. Think about you have a fleet of robots. You have more than 100 robots, each one running different applications. Some of them are not even from the same company, let's say. But let's talk about the ones that are yours and is your software with different optimizations tailored for different applications accordingly, okay? So yes, that is an issue, and it's an issue that many robotic companies face, not only on warehouses, but in general. The first step is your architecture. The moment that you design how are you going to make your models, how is going to be break down your application, is the first thing that you have to consider. And unfortunately, today, due to the dynamics of the startup life, due to the dynamics of the market, companies don't think about that enough. They just try to build a first prototype that works. And once that works, they take that prototype as their MVP and they deploy it. And then they see that the modular architecture that they took, if any, is not modular anymore. Okay. According to your application, according to the different features of your robots, you will have more or less different parts, okay? I cannot tell you which parts you have to create. That is up to you and your type of architecture. But some of the things that Snaps allows you to do is to break down your application into different modules, okay? So, for example, let's say that you are working with two ROS, two Humble applications. You can break that down into a core package of ROS applications. So that is all everything that is ROS core and so on. And that could be your one stable module that is feeding information to your application A and your application B. Okay? Now then, you will see that depending on what you want to update, it will be only A, it will be only V, it will be AV, and also this core fundamental module that you created. And that is the process that you have to do at the beginning when you're doing that architecture. How I'm going to break down my application, how many different modules in order for me to be easy to update these things. And yes, it's a difficult problem that each company have to address, but just to give you an example of how bad things are today. Some of the biggest manufacturers of robotic arms, they don't update anything in the robot for more than 20 years. They could have thousands of CVE, security patches that have not been applied, and they don't care because of that. They are afraid of doing what you just asked me, how I can update and orchestrate all that. It's an issue, for sure. It's not a reason not to make any updates on your robot, because that's a huge vulnerability that you're introducing to your customer. But it's a call to action for every single startup to think about how they're going to break down their architecture in order for them to have a plan for upgrading, okay? We just provide you with infrastructure. We cannot go to that level of which application and so on. But again, having that modularity is one of the benefits of using the snaps, okay? Hope that that was somehow useful. We can talk more about that later, and you can tell me more about your application. Any other questions? You can also ask questions about the Tesla robot and all those things.
Thank you, Gabriel. So just asking, let's say we have thousands of robots sold already and use Ubuntu Core and plus Lab install the software. And then we want to upgrade them. So as a developer of this robot, where are we going to push our updated packages and how the robot get the new update? Thank you.
So, one of the things that is running on Ubuntu Core is systemd. Systemd will allow you to run Snapcraft. Snapcraft will allow you to update things on the robot. So you were part of the workshop of Snaps. If you're interested in learning more about this, and I'm talking to the people live there, you can go and visit Robotics Snaps documentation, and you will find documentation, and you will do basically the same workshop that you were part of. So at the end of the day, we were talking about the store, right? Let's go to this picture. There we go. Perfect. So as you can see, there's two big ways that you can make your Snap available to your devices. One of them that we make available to everybody here is for us to host your Snap in the Snap Store, okay? So let's say that you want your Snap to be widely available to anyone. It's going to be living there, okay? Users can then can install and update accordingly to their needs, okay? Now, let's say that you have your line of devices and you want to have that granularity. I want to update all of my fleet A. I want to update later fleet B with a Snap 2.3. I want to update fleet C with snaps A, B, and C. To have that level of granularity, we provide a service to companies that is our private brand store. With that, it's a paid service. I'm saying that up front. You will be able to have that level of granularity and have that software fleet management architecture that you can utilize. If you don't want to use that and you want to develop your own, you can do that. At the end of the day, as you saw on the workshop, you are creating a file .snap that you can choose how to use, you can choose how to deploy for your users and so on. Okay? Cool. No more questions?
Any more questions? Okay. That means we are done for now. Thank you so much, Gabriel.
Thank you.
Okay, so we have a break of about 17 minutes. Our next talk starts at 5 o'clock. Okay, we start in 1 minute. Paging Frederick, paging Frederick. Okay, welcome back. Our next speaker is Friedrich Fechtmeier. He'll be, okay. He is a Ubuntu developer. And also for him, I had to do a little bit of socializing to get a little bit of information apart from the developing. He is part of the Jaro projects and also Flutter development. He is a husband and father to 2 beautiful children. Yeah, he's from Germany, so I'm hoping that he will be teaching me a little bit of German. And today he will be sharing with us how they or what they are doing with the Ubuntu Software Store app. So I'm looking forward to hearing your talk. Thank you so much.
Hi everyone. Yeah, so I'm Frederick and this is what I'm talking about today. How we're making the new Ubuntu software app. So first of all, I'm not introducing myself. It's like we are more people who are making this app. So we live on GitHub. It's basically, yeah, how much time we got left. Some of us have more time than others. Yeah, and shout out to those guys. Okay, so the first question is why would you want to create a new store? Because there is already a store in a store front end in Ubuntu, and it was more like a private experience. I got Ubuntu installed on my father's computer, and he was like exploring his computer and like, why shouldn't I try this store app, right? And he just clicked it and it crashed. Yeah, so this is my impression that the current store doesn't really perform optimal, and it also is a little bit tricky with handling local Debian packages. When you download, for example, Google Chrome or Discord, it could be a little bit better. And also, from my experience with the Yaru theme, we often got like requests for the icons of the software store applications that are installed. And there are like at least 3 applications handling something about updates. So if people like searching GNOME shell for something about updates, there are like 3 apps popping up. And it's a little bit confusing. So this is another reason why I thought this should be like unified inside one application. And also, yeah, so the next thought could be like, well, why don't you just improve GNOME software then? And in this, I'm a Java developer. This is what I learned. So I'm not really good at C, and especially not really good at the GNOME C stuff. It's special C libraries and so on. Yeah, So, but I'm actually also quite okay with coding in Flutter. And yeah, so why Flutter? Because it builds fast. You can develop fast applications, and it compiles to native binary on Linux. So it's actually it starts up like any other binary, and also because Dart is a really nice modern language, and as a Java developer, it was really easy for me to get into it. And currently, when I go back to Java developing, I'm always like, I can't do this in Java, and I'm always happy to be back in Dart. And also, there's a huge developer community around Dart and Flutter, so it's easy to get help, and and of course also because Canonical has done already huge investment in Flutter on the Linux desktop, so it's quite easy to get started. So the first question is, if you want to make a new store, like what do you want to get in Ubuntu? Of course, Snap packages, Debian packages, and you also need like trivial stuff. It sounds trivial, but it's actually not. But you need it, like accessibility, localization support, different languages, and also, of course, very important topic for me is Ubuntu design and look and feel. So this should need to go in. And of course, it needs to perform good, at least better than the current store. And also optional stuff like notifications, network status, and it should be packed as a snap, and it should be access the GNOME shell and the session. So where do you get all this stuff from? So luckily, there was already like a huge investment by Canonical, as I said, so most of the stuff was already there. And sometimes it felt like a shopping tour. So it's like, okay, let's get started. I need a library for Snap. Oh, it's already there, so awesome. I can use it, I can get it. And it's made by Robert from Canonical. So let's get it in. Next, Debian packages. It was also nice. It's not only Debian packages, but it's an API called PackageKit. It actually uses dbus, and thankfully it was also already there. So what a surprise! I get that one in as well, and it was a tricky part for us because the Ubuntu design and look and feel was not yet already perfectly in material at this time. We got the Yarrow theme, but the Yarrow theme is more like makeup for material widgets, so it wasn't really perfect. So we needed some more libraries to get the whole look in. So yeah. All right, so we got the Yarrow theme in, which is, as I said, only the makeup for material. But there was like a huge urge to get more in, and so we created this Yarrow widgets library to fill the desktop gaps that material leaves, because material they're getting there, but it's sometimes like something is missing. For example, like the sizes are not always perfect, and also multi-page support is not perfect. But we created it, and I get to it. So this is like the Yarrow widgets example. You can also run it on the website, because Flutter also supports being rendered in the browser. So this is a widgets library. I won't go through all those widgets now, but I hope it's complete now. And also we needed the icons, because this is also, in my opinion, apart from the Ubuntu font, the icons are really extremely iconic for Ubuntu. It's like those sharp thin strokes, which are really like, it's really characteristic for the look. And thanks to Paul, we got that in it well. I didn't commit a single commit on this repository, but it works perfectly, and it's like the same API as the material icons. So you can just create an icon widget and insert the Yarrow icons icon data. It's really nice. Thank you, Paul. Also, there's more. GNOME applications look really good, and one modern GNOME applications like GTK4 and other GTK3 windows, and one puzzle, one part of this puzzle is the rounded window corners. Maybe some people don't even recognize it, but yeah, if you're like a little bit of an aesthetic, you see it and you want it. And so thanks to JP, who is currently, I think he catch some cold. He got some updates to his immune system here. So we got that in as well. Awesome. And of course, the performance needs to be good, but thankfully, Flutter already performs really well from the stable channel. And of course, you shouldn't code like really bad. So some smart design patterns were also used, like the observer patterns and stuff like this. Notifications, thankfully, were also already available, so we can shop this one as well. Thank you, Robert. And for network status, this was also something really strange in the software app, which is currently live. That it's not really handling like network losses really good. So it's when it's off, I think it caches some images, but then it's not really handling this one well. So we needed a package which can which listens for the network status, and thankfully to the Flutter community, it's not our smaller community, it's just a wider Flutter community. This is also there. It's a multi device package, so you can use this package for Android devices also, iOS, macOS, and so on. Yeah, and also it needed to be packaged as a snap, and thanks to Ken, he helped us with that, and Olivier. And we needed access to GNOME Shell to like make reboots and restarts, so we got the Ubuntu session thanks to Dennis. Okay, so here's the shopping list, and as you've already noticed, we got even the optional stuff in, so everything is inside. That's really nice. Yeah, that was one of my first sketches. It's really rough, but it was the first idea, like a catchy starting page where you can scroll down and you see banners of applications. And this was an advanced sketch for a wider window. But this is not really how all this stuff came together. To be honest, the first thing we did was like get the features inside before we care super hard for the specific pages. So those 17 goals, I won't list them up. It's like install snaps, remove snaps, refresh snaps, and the same stuff for Debian packages and so on. Those are the 17 goals. And also it was because in previous projects, or like the Yaru GNOME theme, we are so super used to GitHub that we wanted this also to be for this project. So everything basically happens on GitHub. And we also got like CI and CD with testing in, and if everything goes correct, we push it to the Snap Store. Yeah. Then what we did was like iterating over the pages. I started with some rough pages while it was really improved by our work on GitHub. So I won't go over all of them, so let's just pick one page, the updates page, which was recently revamped by our team. And I have no picture how it previously looked, but it was a little bit bulky, like too many stuff happening on the screen. So Mats, our designer from the community, jumped on GitHub and made this mock-up. I think it's Photoshop or something. It's like it's nothing like everything is drawn with some tool. And he said like most of the users don't really care for, wow, you got an update for lib 33.405 deb, right? So the normal user just wants to see you got updates, you can update them and you're done. So, but if you want, you can expand this panel and you see what you want to update, and you can select the updates. He also had more ideas, like for when you got a new release, but this is not in yet. This is the idea for the updating page. But for the first idea, I came up quite fast with an implementation of this design. So this is how it looked at the first try. And this happened. What always happened when we work on the team is like it's like an iteration in a small group, and we can improve quite fast on one GitHub issue. And it's like Paul and Matt's come up and we talk about this, and it's not always often you need to change your opinion. So it's sometimes a little bit hard process, but most of the time something really awesome happens. So I got some feedback, and this is the current result of the page. And I don't know if it's visible, but in my opinion, it looks quite awesome. All right, so what's the current status of the rest of the pages? This is a landing page. Like, this is the explore page where you can scroll down and you can search for packages or snaps. This is a search page, and you can also select what, also a hot topic, like what packages you want to select. And so only snap packages or Debian packages or both. So if you only select the snap packages, it's a little bit simplified. And if you click one of those search results, you land on this app page. That's how I call it. It's the page of the app, right? So it looks the same for both package formats. But it was also important to get the size of the page adapted to the window size. So it's a fully adaptive page. When you move the window, like when you make it very narrow, it switches to this narrow view, and you can just scroll it down like on a smartphone. And this is the wide view, because most of us are sitting in front of a big screen, so it's also important to get as much information into the screen as possible. And on the right side, you can scroll it down, and you see more like permissions, ratings, and stuff like this. Yeah, this is I hope you're not blind now. This is a light theme. Yeah, but that's not all. This was our community stuff, minus the packages, which comes from Canonical, of course. And every week we got a weekly meeting with Canonical designers and engineers, which help us like iterating over goals and pages. And we recently got the unified search in, was a big topic. And also thanks to Olivier, the package kit management has been improved very much, so it's a lot faster now. And the next idea is to outsource the updates mechanism, so like a systemd service running in the background instead of the app, because this is also a problem of the current approach, like a long-living process which sometimes crashes. Okay, so there were nice side effects by this whole tour. So what's possible now in general with all those nice libraries? Today I had a workshop about how you can create a desktop application in our look and design. So it's now possible to, if you are a normal developer and you want to create an app, so you don't necessarily need every time a designer to create your application and it looks like an Ubuntu app. I think this is awesome. So because designers don't have much time, they're like really like unicorns flying around, and you try to catch them. Hey, what do you think of this? And then they're already gone. So it's nice to have a working, consistent toolkit which can be reused. So this is what we got. So we can create also wizard applications like the new Ubuntu installer, but this was not my work, or our work. And yeah. So also we can fill the GNOME gaps now. So if we want, we can create new applications if we feel like we need to reinterpret some of the desktop applications. And also, this is also an advantage of Flutter, because it's actually also used for mobile applications. So all the stuff is already there if you want to connect to clouds like Firebase, Microsoft Clouds, Amazon, or this open source project, which I highly recommend, Superbase. It's a really nice alternative to Firebase, and it's fully open source, so everything is there. So if you want to create an application which actually talks to the internet, this is a lot easier in Flutter. Okay, and what's next for us, for a smaller community team? It's just for the community. We want to improve the widgets, because it's perfect, but we always find something which can be improved. Eventually create a Files app which can contact Google Drive, and finish the Settings app project, which was also really helpful to get some widgets in. Yeah, this is like an experiment of mine. It's a little Files app, so this is also possible just out of the box. This is the Settings app, which I eventually finished someday, but it really helped a lot by, which is a really classical desktop application, and it's really, yeah, you need really much for this multi-page application. It was basically the reason why we've created many widgets. And there's a last thing I want to talk about, and this is really awesome. The guy who's sick, JP, also managed to get the last bit of GTK out of the window. So it's like, it was, from what I've read on Discourse, and so it was a bit criticism of users that it's like a mixed window, like with a little bit of GTK and a lot of Flutter. So now it's possible to just, it's like a slave window where everything Flutter is inside and there's no GTK widget inside. So you have full control over the looks, which is quite awesome. And yeah, this is also possible now, but it's also really new. So I try to get this into the software app as soon as possible. All right. Thank you very much.
Thank you, Frederick. Okay, we have one question there. Is our mic ready? We have 5 minutes, I think. We have a lot of time.
Whoops. Any question?
Hello. First of all, congratulations on all that excellent work to everyone involved. My question is, having watched this, Yannick and I have just sat here and we're going to abandon the work that we're doing, refactoring our software boutique, and we would like to use this in Ubuntu Mate. So are you open to us working on an alternate implementation of the session management stuff, because that works slightly different in Mate from GNOME? Can we contribute?
Sorry, I didn't really get it. I'm not a native English speaker,
Sorry.
I'm sorry.
One of the components that you identified in your shopping list was integration with the GNOME session.
Yes, some of them were integrated, most of the stuff is actually dbus based.
Right.
For example, actually most of the stuff is dbus. So it's dbus interfaces that need to be implemented in Dart. So this implementation has been packaged in some Dart library, for example, the session.
Yep.
Yeah.
The dbus namespaces for the Mate desktop are going to be different. So are you okay for us to provide an alternative?
Yes, I think this is also already what you said is already has been in the design, that the sessions can be different. It's not Ubuntu specific. Yeah.
Great, that's excellent.
Okay.
Do we have another question? Oh, okay.
Hi. I might have missed it, but is there a plan for this to become the official Ubuntu app?
Yeah, I think so. Yeah, Ken is raising his thumbs, so it means it's going to be official. You can all.
When?
Yeah, you can already test it actually. So if you change the channel of the Snap Store to the preview channel and you refresh, you first need to kill it, but then you can refresh it, and yeah, you got the update. You can already test it.
And for ratings, are you thinking of?
Yeah, this is actually the only part inside the Soul application which is a mock-up. Everything else is fully functional, but the rating is like, it's a mock-up. It's inside like some funny stars and so, but there's no backend for it. But it's coming, I think.
Were you thinking of integrating with the open rating system, or creating a new backend?
No idea, no idea. I'm for the makeups. I have no idea.
We haven't really fleshed out all the details there, but we are planning something now. I'm not sure if it'll be ODRS or not. Personally, I would love something that's integrated in the store, but we're working on that now.
Can you help me with the UI of Ubuntu Accomplishments, please? Can you help me with the UI of Ubuntu Accomplishments, please?
Yeah, of course, yeah. Why not?
Thank you.
As Ken has said, that when it's ready, it will be seeded in Ubuntu. Can we seed it in Ubuntu Mate beforehand to get some early testing feedback? Because I don't mind being a guinea pig. All right.
So, this would. So, like the GTK applications that you're replacing. So, GTK applications, they do have a lot of polish. They're really nice polish, but they're really they're really painful to get it to the polished state. If you are replacing it with like Flutter application, do you find that it's quite difficult to get to that kind of level of polish? I mean, not just the look, but the feel of the application when you're like working on the components.
I'm sorry, I didn't understand this.
Okay, so the GTK applications that you're replacing are quite polished, right? Like the feel of them. But the Flutter on desktop is a little bit wonky. Like, for example, if you have like a popovers with the keyboard navigation and stuff like that, do you find yourself that that's quite a bit of work still to get that to the kind of level of polish that the existing applications have?
Well, the keyboard navigation already works quite well. This comes from material, not actually anything we've did, but of course there's room for improvements, yeah? If this answers your question, if not, sorry.
Spend like on the Flutter, like polishing the feel of it on desktop.
I can't really answer this question, sorry.
Thank you so much, Frederick, again. Our next session will start at 5:30. It will be the lightning talks. So see you in 4 minutes.
Can all Lightning Talk presenters come to the front of the stage, please? All Lightning Talk presenters come to the front.
Okay, we are about to start. We are about to start. Okay, so as we all know already, there's only one rule when it comes to lightning talks. We let them speak. The lightning talks are either 5 minutes or 10 minutes. So when the time is up, we will hear a sound from here. And if our speakers continue speaking, we clap for them starting gently, and then we keep going louder until they're not able to speak. Yes, that will be the only rule. So we are not having any speaking in between. So our speakers, can you please come to the front and then just switch as quickly as possible when the lightning talk starts. Rudra, are you ready? Let's start.
Hi everyone. I'm Juju and I'm the project lead of Ubuntu Unity, Ubuntu Web, Ubuntu, and I'm also an Ubuntu member. So I'll be talking about contributing to Unity 7 and Ubuntu Unity. So in the next few minutes, we'll be discussing the current state of affairs, that is, the features added in Unity 7.6 and Ubuntu Unity 22.10, and then the features planned for the next release, and then how you can contribute to Unity 7, and then the various ports of Unity 7 for other distributions. So beginning with the features in 22.10 and 7.6. So the changes include dash, hard, and other UI elements being redesigned with a much flatter and modern appearance. And then support for accent colors was added to Unity Console Center, and many other bugs such as the theme list being empty were also fixed in Unity Console Center. And then other bugs such as the empty trash button not working were also fixed. And then a new drop-down to toggle between dark and light themes and change accent colors was also added to the panel. So then the features planned for the next release. So Ubuntu Unity 20.04 will be released with all the other flavors in April next year. So we are porting the new unofficial Ubuntu settings app, which is still work in progress and is written in Flutter to Unity. So I'm sure French guy CH would be very happy hearing this. And then we are also considering working on the new welcome app for Ubuntu Unity 23.04 written in Electron or Flutter. And then we are actively replacing all the remaining GNOME apps and dependencies. So now, let's discuss how you can contribute to Unity. So you could help port Unity to a distribution of your choice and become the Unity maintainer for that particular distribution, or you could help add new features or fix bugs in Unity. So I've given a link for where you can submit new merge requests to Unity. And then you could also join, and then if you face any problems, for example, you could join the Ubuntu Unity Telegram group or Discord server. So I've given the links here in the slide. Also then, porting Unity 7 to other distributions. So Unity 7 is available. So Unity 7 is actively being ported to other distributions such as Fedora, Gentoo, and Arch. So beginning with Unity 7 on Gentoo. This port is based on Unity 7.6 and is extremely stable. In fact, so I'll actually be doing. I would have presented from that, but since this is a 10-minute talk, I won't have enough time to show Unity 7 running on Gentoo. So yeah, I've given the links for the GitHub repository and the Telegram group in this slide. And this board is maintained by C4PP4, who I would like to give a huge shout out to. And so here's a screenshot of Unity 7.6 running on Gen 2. And then Unity 7 on Fedora. Yeah, Unity 7 is also now available on Fedora. So this board is based on Unity 7.6 and is pretty usable and stable. However, there are a few bugs which are left, so Cat Master is actively fixing them. And there are a few missing packages. But apart from that, yeah, like I mentioned earlier, it is pretty stable and usable. So again, I've given the GitHub repositories link, and yeah, it is maintained by CatMaster21, and then Unity 7 on Arch. So I was actually working with Marco Tevison here. I was working with him right now a few minutes before the talk. So barring one or two tiny issues, it is pretty much ready for Arch. So all the Unity packages compiled successfully and have been packaged for Arch, and this board is maintained by me. So yeah, thank you for joining this session. I've given my contact details here, and yeah. All right, so see you all next time.
Hello everyone, my name is Marina Castejon and I'm a UX manager at Canonical and part of the Accessibility Guild, an internal initiative focused on making Canonical's products and UIs accessible to everyone. Today I'd like to talk to you about digital accessibility and how we can all be more mindful when we're building and designing software that's accessible by design. I will start, however, with an example of physical accessibility. So there once was a man who saw his wife struggle while peeling potatoes. She had arthritis, and peelers before used to have a thin metallic handle. So he designed an improved peeler. And one of the improvements was a thicker handle that was easier to grab, inspired by the comfortable rubber handles on bikes. So this innovation had a huge impact in the world of industrial design, and bear in mind that the brand behind this, called Oxo, they didn't market this as a peeler that was good for people with arthritis or motor impairments. This peeler was better for everyone, and that's why nowadays all peelers have much bigger handles. This is only one of the many examples where a focus on accessibility and inclusive design benefits everyone and fosters innovation. So the principle of inclusiveness is also aligned with the mission of open source: no discrimination against persons or groups. The rationale explained in the open source initiative states that in order to get the maximum benefit from the process, the maximum diversity of persons and groups should be equally eligible to contribute to open sources. If our ethical responsibility wasn't a solid enough argument, there are other factors that should make accessibility a top priority for anyone building software. So on one hand, there is legislation. Over the years, there have been different mandates or laws that enforce digital and non-digital accessibility. So one example is the Americans with Disabilities Act in the USA in 1990. And in the European Union, we have the upcoming European Accessibility Act. So the deadline to comply is June 2025. And a wide range of sectors and products and services must be accessible, or companies will face legal repercussions from the European Commission. This mandate impacts, among others, e-commerce sites and operating systems. So Canonical and Ubuntu are obviously impacted. The good news is that up to now, regardless of the legislative body, the standard for compliance is always the W3C Web Content Accessibility Guidelines, which you might have heard referred by the acronym WCAG or WCAG. So apart from avoiding fines, another very good argument to work in accessibility is that accessibility is not a niche market anymore. W3C estimates that there are 1 billion people in the world with recognized disability and with a spending power of more than $6 trillion. Before we go on, I wanted to take a second to explain that when we talk about disabilities, we tend to think about prototypical depictions of disabilities in the media, such as visually impaired people using a keyboard or someone in a wheelchair. But nowadays, we know that as the world population is aging, there are a lot more people who will see their abilities severely decreased, even if they don't identify themselves as someone with a disability. And the way these people will use software will change because their needs and abilities will have changed, and therefore, software design should adapt to them. And on the other hand, we have to take into account people with a temporary, invisible, or contextual disabilities, and also neurodiverse people. So now, how can we make open source software accessible to all? So there are many gray areas when it comes to digital accessibility compliance. As I explained before, so there's the web content accessibility guidelines, and they provide success criteria. And lots of details and recommendations. But for complex components or interactions, sometimes the solution is not there. So we often need to think creatively to come up with solutions that will make the product accessible. So when WCAG doesn't alone give us a straightforward answer, there is a concept that I keep coming back to time after time to assess whether something is accessible or not. And that is the principle of comparable experience, which states that you have to ensure your interface provides a comparable experience for all, so people can accomplish tasks in a way that suits their needs without undermining the quality of the content. This last part, undermining the quality of the content, is the key to understanding what is a comparable experience. So accessibility can be complex and daunting, but you may start with one general rule of thumb. If you want to improve the accessibility of your products and services, and that is that usability and accessibility go in the same direction. What improves usability improves accessibility and vice versa. And at the end of the day, accessibility just means better usability for everyone. So here's some things, quick checks that you can ask yourself about the software you are building right now. Can a user interact with the system using different input methods, different than a mouse? So you can quickly check this, for example, by trying to use the system with a keyboard only. On the visual design side of things, does the UI respect the minimum color contrast ratio? Is the language easy to understand? Content design is really key for accessibility. Are error messages clear? Does the system explain what went wrong to the user, and how can the user recover from that error state? And last but not least, another check you could do is to see if it's usable with a screen reader. If you want some tips on web accessibility and how to use Orca, an open source screen reader, my colleague Scott gave a talk on this topic, and if you want to check that out, it's called Simple Web Accessibility Checks featuring Orca. Thank you, everyone, and now it's time for questions.
Yeah, my name is Harald. I have the pleasure of speaking to you about secrets in KDE Plasma. I'm a KDE engineer, and surprisingly enough, many KDE engineers didn't know these secrets either, so they must be really good. That's Plasma, of course. It's KDE's desktop offering. It looks quite lovely, if you ask me. So what can the desktop do? The desktop, you can middle click on it and you create a sticky note. It's already cool. You have spring-loaded folders. That's the thing you can see in the screenshot, where you open a folder and it opens a folder, and you open a folder and it pops up another window, and so on and so forth. It's like nesting dolls, but with folders. You can drop an image on it. You can change the accent color based on the color of your wallpaper. The window manager, Quinn, also has a bunch of lovely features. You can hold the Meta key, the Windows key, and move any window around from anywhere in that window. It's really, really useful to arrange windows. Of course, we have window effects, like the lovely one in the screenshot here. It would be even better if it was animated, because it's wisps animating the window out of thin air. It's absolutely amazing. Of course, there's also accessibility stuff, like you can zoom in if you want to and zoom out again, obviously. Oh, and there are so many settings. It's worth exploring. The task manager has also a bunch of useful features, and we are now entering the realm of what I call the scrolly wheel interactions. It's when you use your scroll wheel to do stuff. So on the task manager, you can scroll to walk through all the windows in the task manager. This is really cool, although I don't see the use in it. There are these tiny, media overlays. Now they are super useful. If you look carefully in the screenshot, I hope you can see it. Yeah, just about. On the VLC icon in the top right corner, there is a volume icon. That is actually interactable. So you can click on that icon and mute this application without ever opening the application. That is so cool. And the same also works for microphones. So if you're in a video chat and you want to mute yourself very quickly, you can use the task manager. Moving on to the system tray. Now, the system tray has the ability to pin itself. So this is like the pop-out version of the system tray. You can pin it so it's always open. It's useful for when you're trying to figure out why something isn't working, like maybe you're doing a presentation and you're trying to do a live demo, but the live demo doesn't really work. You might be opening the system tray and inspect the battery, for example, or ensure that you're in presentation mode. And of course, you can also have configurable time zones. So you'll probably not see it. It's a bit tiny in the bottom right corner. There's the time zone Vienna, but there's also the time zone for Sydney. That's also super handy. So you can always keep track of where your colleagues, your remote colleagues are. And oh, there are so many things in the system tray stuff. So you can wheel on the volume icon to change the volume. You can also middle click on the volume icon to mute it. Super handy. You can also drag applications around in the volume applet to give them different outputs. You can also click on the microphone icon to, well, mute the microphone. Then there's, of course, this lovely media player widget, which allows you to control just about any media player without ever going into the media player. Then you can get the QR code for the currently connected Wi-Fi. You can get the QR code for whatever is in your clipboard. You can enter presentation mode, so you do not get disturbed while giving a lightning talk. Then there's KRunner. KRunner is super old. It's one of the features that everyone loves. You bring it up using a number of different commands. And then you can do all sorts of stuff. So you can find all the plunder you could possibly wish for. There's going to be apps and activities and bookmarks and browser tabs and documentation. Oh, it goes on and on. You can use it as a calculator. You can also use it to check the date and time, also in a different time zone. Super handy as well. You can also use it as a dictionary, or maybe as a spell checker, in case you're not quite sure how to spell engineer. There's also unit conversion, various system operations, and so much more. Oh, you could kill Firefox with it, literally. Thank you.
Hello, everyone. Thank you for being here. And I'm the last talk, so I'll make sure to use the entire 5 minute up. Okay, so my background, I'm a developer for 15 years. I open mostly in the LAMP stack, so that's of course Linux, Apache, MySQL, and PHP. I'm a cloud enthusiast, and I actually run a community in the Philippines called the AWS User Group Philippines. But aside from that, I'm also an instructor, and I also help startups get into the cloud itself. Okay. So a short background of our community. So our community has been running for over a decade, 9+ years. We have around 11,000 members. And every year, we have regular activities and solutions. And we actually track real impact stories. Stories like users or members that went back to the Philippines once they adopted, or at least adopted the technology. Or perhaps they got promoted in their job or career shifted because of the technology, okay? And our user group particularly has won among other user groups in AWS in Asia Pacific specifically. Oops. So what is a community event? Is it just free pizza and drinks? Now, there are obviously sometimes when we think, hey, it's a community, there will be food, there'll be drinks, there'll be beer, but of course, that is maybe our come on, but we should understand what is our community for. Is it a contributor community? Is it a user group? Because those two things are quite different, okay? In our user group community, our aim is to have mentors because the IT space is such now a very large industry or large space. When you're previously, I've experienced this, your IT, can you fix a printer? If you're IT, can you fix something else? Right now, it's so large now that we really need, not just for us, but also for the next generation to filter out the exact needs. Okay? So again, here are just a couple of benefits why we are in a community. Filter technology, get exposure to the World Wide Web or the world technologies. You can also look at the locals, right? It's local, interactive, so you can have a safe space to be in. And if you also are a contributor, it actually pushes for your own growth. Okay, you might be shy like me before. I'm still shy now, but here I am in Prague giving a lightning talk, right? So of course, some learnings here. Number one, running a decade-long community, sustainability and consistency is hard. So that's why you need to know your passion. My passion is education, okay? And so that's why I continue to do this, because I want to teach more and more people, especially those that don't have access to a particular technology. Of course, I take breaks. Don't forget to not overburn yourself. Also remember that in your community, each person is different. Each person has an agenda, right? It's hopefully for the good agenda. And of course, understand that some people need more help than others. You cannot have a generic approach to everyone. Okay, so understand that there's multiple membership in your community. There's general, anyone who's curious, attend, right? Maybe they'll come once, twice. There's that regular attendee, okay? And hopefully they become speakers, mentor, they become regular or irregular. They'll volunteer, and of course your core. And I put a little icon there for the technology community manager. Usually if you're based on a technology, then you actually also need help from the technology itself. So from Canonical, community manager like Philip, right? And of course, every activity or every member should have a activity that's addressed to them, okay? So for general, you can have your social media, Twitter, Facebook, meetup.com, okay? For quick and easy information. For your attendees, you have regular meetup, because this is where they can gather, have a face-to-face interaction. For those that are more advanced, you do workshops and code camps, okay? Next, study sessions. Really, this is like a curriculum that's available to everyone. Appreciation dinners, leadership seminars, you'll have job portals and swag stores, etc. Ayan. So thank you. Just remember this slide.
Okay, and that, ladies and gentlemen, marks the end of day 2. Game night starts at 7 o'clock at Palm Cover rooms 1 and 2. Please take pictures of whatever you'll be up to tonight and take us, and have a wonderful evening.